Let's take a ride. More to come in this marathon.
While experiments and missions in space sometimes get significant press attention, they also sometimes get generally forgotten or get little coverage at the time, leading to some amazing things that have happened in the course of human space exploration that you might not know about. So here are 10 obscure but amazing past space missions. Number 10. Venera and the surface of Venus. While images of the surface of Mars are quite common after multiple successful landings by NASA, as are pictures of the moon's surface due to Apollo and other missions, there are other objects we've landed on in the past yielding photographs that are not so well known. For example, the surface of Venus. In the late 1960s through the 80s, the Soviet Union, in an ambitious series of attempts to build space probes that could land and survive for a time under the very harsh conditions present on Venus's surface, they managed some surprising successes and even photographed the landscape. This is the surface of Venus. What you are seeing here is atmospheric pressure 92 times higher than the surface of the Earth, equivalent to being about a kilometer deep in the ocean. The deepest anyone's dived without a submarine and survived it on Earth is just above 300 meters. And you are also seeing astonishing temperatures here, 462 degrees Celsius, far hotter than a normal kitchen oven. The yellow color is the atmosphere of Venus, which is largely carbon dioxide and sulfuric acid, certainly not something you could breathe. Given the crushing atmospheric pressure and extreme heat, these probes typically did not last long, minutes rather than hours or days. But they were a scientific success and yielded to us our only set of photographs that we yet have from the surface of Venus. Number 9. Russia and Mars. While the Soviet Union had remarkable luck with Venus, given the conditions of the surface of that world, they had very little luck with Mars, with mission after mission over the decades failing. But they do have one distinction. They were the first to successfully land a functioning lander on Mars. It was called the Mars 3 lander, but it only transmitted for about 20 seconds before falling silent. While it did return a single image, it was simply a gray screen with no real discernible details. Still, it did transmit at least something from the surface of Mars. As to what caused the failure, it's not known, but at the time Mars was engulfed in a planet-wide dust storm, which might have induced a coronal discharge, destroying the communication system. Number 8. Space tomatoes. NASA has a long history of sending seeds into space, most notoriously the moon trees that I've mentioned on this channel, which were grown from seeds taken by the Apollo astronauts to the moon and can still be seen dotting the landscape in various places in the US. And while the moon trees do certainly have the distinction of having been to another world, there are, at any given time, numerous, perhaps thousands of other plants in the world growing from seeds that have been to space. NASA's history of sending vegetable seeds to low Earth orbit is extensive, and there's a good reason to do this. If we're going to colonize the solar system and grow food on space missions and eventually giant O'Neill cylinders, we need to know how that affects the seeds. So starting in 1983, NASA began including seeds in missions, and by 1984, they had literally sent millions of tomato seeds up on the Space Shuttle Challenger to be distributed to classrooms to be grown by students, including a then 9-year-old me. And yes, I ate one of the tomatoes. This has been repeated thereafter in conjunction with the Canadian Space Agency. Seeds that have been to space continue to be grown by kindergarten through 12th grade students. And in 2006 and 7, tens of millions of cinnamon basil seeds were sent to the ISS and then grown back here on Earth. Generally speaking, the seeds do well after having been in space, and there seems to be a great promise in the idea of growing food in zero gravity in the future. As an aside, not only have tomatoes been to space, but some of them even have space-related names. Russian space engineer Mikhailovich Maslov was also an avid gardener that developed strains of heirloom tomatoes. One particularly nice strain he bred is grown today in gardens across the world, and bears the name of his friend cosmonaut Vladislav Volkov, who died in a re-entry accident in 1971. To try this bit of space history, you'll probably have to grow the tomato yourself, unless you get lucky at a farmer's market. But the seeds of the cosmonaut Volkov tomato are widely available from seed companies. Number 7. Visiting your own unmanned spacecraft in person. In 1967, NASA launched the Surveyor 3 spacecraft from Cape Canaveral on a mission to land on the lunar surface to help prepare for manned missions to the moon. In particular, the spacecraft studied the lunar soil to determine if it could support the weight of a full-on Apollo lunar lander, along with collecting scientific data about the soil. But even after it had fully finished its mission, it still had work to do. In November of 1969, Apollo 12 landed on the moon just 600 feet from Surveyor 3. The craft was then visited by astronauts Alan Bean and Charles Conrad Jr. Human astronauts visiting spacecraft in general is nothing new. The Hubble Space Telescope was serviced multiple times in space. But humans visiting their own remote spacecraft on the surface of another world is something else entirely. But I doubt it will be the last time we do that, as it seems likely that someday someone will visit the defunct landers that dot the Martian globe and maybe bring one home. Number 6. Parachuting to Mars. In the history of human space exploration, we have plenty of footage and photographs of deep space probes being launched. That's easy enough when you have someone standing around with a camera on Earth to catch it. But landing is an entirely different thing. There are not yet people with cell phone cameras standing on other planets. But surprisingly, we do actually have a photograph of a space probe in the process of landing on another world. It was the Curiosity rover parachuting its way to the surface of Mars, and this photograph was snapped by the Mars Reconnaissance Orbiter as it made its way down to the surface of Mars in 2012. Getting MRO to snap this image involved some serious spacecraft acrobatics and very good timing, but they got it. So there you are, an image of a probe from Earth in the process of landing on Mars, where it's still operational and doing science to this day. Number 5. Huygens and the surface of Titan. Mars is, in most ways, the most Earth-like planet in the solar system, and when looking at pictures beamed from its surface, it might look different, but yet not completely alien to Earth. That's what makes it Earth-like, and it basically looks like a red Earth desert with a little less sunlight. But there are landscapes that are far more alien in our solar system. One of these is Saturn's moon Titan, and we have also landed on it and photographed it. Imagine what you're seeing here. Unlike Venus, this is a very low temperature environment, about negative 179 degrees Celsius or negative 290 Fahrenheit. That's not surprising. Titan only receives about 1% of the sunlight that Earth does. As a result, water is essentially a rock on the surface of that moon. But because of those temperatures, we end up with a kind of analog of Earth. Titan has liquid on its surface in the form of hydrocarbons, and even an analog of Earth's water cycle with those liquids. Given that there is liquid on the surface, that opens up the door to a very low temperature form of life, if it's possible. This hasn't been confirmed, but it could be that the landscape you see here is teeming with very alien, very low temperature microbes. Number 4. Impacting a comet. It may seem improbable to pull it off, but the best way to study the interior of an object in space is to fire a large gun at it and see what comes out. And we once did that, sort of. On July 4, 2005, NASA's Deep Impact spacecraft placed an impactor in front of Comet Tempel 9 and it ran into it. The resulting impact was the equivalent of 5 tons of TNT and caused the loosely bound comet to release unexpected amounts of dust and gas as a result, even causing the comet to rapidly brighten by 6 times what it had been before the impact. The results were somewhat surprising. The comet contained more fine dust than was expected beforehand and less outgassing from ice. They also found carbonates and clays, which typically require exposure to liquid water to form. How those formed is not well understood. Number 3. Seeing the nucleus of Halley's Comet. In 1986, the much-anticipated passage of Halley's Comet occurred. This comet is famous throughout recorded history, having been spotted in 1066, the year of the Battle of Hastings, with its 76-year orbit first calculated and predicted by Edmund Halley in the 18th century, and its 1910 apparition was by all accounts quite spectacular. So, the 1986 apparition of Comet Halley was widely anticipated and planned for within the scientific community. The comet itself, as seen from Earth, was somewhat of a dud. While it appeared in the night sky, it was not the blazing bright comet it had sometimes been in previous passes. It seems to be a rather hit-or-miss comet as far as brightness, but it does have the distinction, perhaps fitting for the most famous comet in history, of having been the first to have its nucleus photographed. In 1986, the European Space Agency sent the Giotto spacecraft to study Comet Halley up close and snap a picture of said nucleus. It was a success and shed new light on comet composition, but there were also some surprises. One was that the probe survived at all. There had been predictions that the dusty environment around the comet would destroy the probe, and despite one impact even spinning it around and possibly even taking a chunk out of the spacecraft, it was able to recover and even go on to study a second comet some years later. Most of the dust itself turned out to be very small, more like cigarette smoke than sand. and the nucleus itself was very dark, suggesting a heavy dust coating. The jets of material coming off the comet due to the melting of the ices forming its coma and tail was mostly water with a mix of carbon dioxide, methane, and ammonia, and a lot of dust. Halley's Comet is predicted to return in 2061. Number 2. Detonating a nuke in space. Nuclear testing these days is considered a bad thing, essentially a global taboo that's mostly banned by treaty, or not pursued at all other than by a handful of countries with less than stellar international relations. But this was once not so, and within the history of nuclear testing and its relationship with space, there are some odd stories. One would be a nuclear detonation detected in 1979 off the coast of Antarctica near the Prince Edward Islands. To this day, no one has admitted to this test, though it's generally thought to have been a joint test performed by South Africa and Israel. But perhaps the most interesting incident was in 1962, when the United States detonated a nuclear weapon in space. This test is known as Starfish Prime, and it did not go well. It caused several problems, including creating an electromagnetic pulse far stronger than what was predicted that knocked out electrical systems and streetlights nearly 900 miles away in the Hawaiian Islands. Effects on the magnetosphere caused intense artificial auroras to be seen, and the test also formed an artificial radiation belt around Earth that persisted for years and damaged multiple satellites. Clearly, it's not the best idea to detonate nuclear weapons in what is also low Earth orbit, but there is an honorable mention in relation to space and nuclear testing. One underground test done by the United States included a manhole cover that may well have been blown into space. It appeared in one frame in high-speed footage getting blown off at ridiculous speed, escape velocity, and no trace of it was ever found. Whether any material from the cover actually did escape into space is unknown. Number 1. Missiles and Kessler Syndrome. One of the big fears of low Earth orbit is the concept of Kessler Syndrome, where the density of objects, space junk, hanging around in low Earth orbit becomes so high that collisions between the objects could cascade and generate so much debris that it could make low Earth orbit off limits to human use for decades. This scenario wouldn't end our presence in space. Other orbits would be available, and launching through a Kessler Syndrome-affected orbit isn't so much of a problem as orbiting within it is, but it would make certain very valuable orbits for human use problematic at best. Space junk is bad, and the various space agencies go to certain lengths to ensure that space junk is managed, such as mandatory deorbiting capabilities for communication satellites like SpaceX's Starlink when the end of the satellite's lifetime comes. But governments at large haven't always been so careful. In the 1980s, the US developed anti-satellite missiles and tested one in 1985 on a science satellite that's batteries were degrading, all of which have now deorbited. But the last one may have been in orbit as late as 2008. In 2007, however, China tested its own anti-satellite missile, destroying a defunct Chinese weather satellite. This event is the single largest creation of space debris in human history, with several thousand pieces of trackable size recorded, and likely over 100,000 tiny fragments were generated that we can't track. They will present orbital threats for some time to the space launch industry. In this list, I had to draw a line at 10 entries, but there are too many honorable mentions to mention, such as the time when the US Navy, only just a year after the Chinese test, shot a missile from a ship at a satellite just as it was beginning to enter the Earth's atmosphere to neutralize its environmentally unfriendly hydrazine tanks. Obviously, the 80s anti-missile idea worked. Or that time we parachuted a probe into Jupiter's atmosphere but didn't take any pictures. Or when we attempted to collect cometary material in interstellar grains passing through the solar system and then successfully returned them to Earth. There's just so much, so I'll probably do a sequel to this list in the future. Imagine the very earliest humans looking up at the night sky. Among the brightest objects they would have seen were the planets, and among those would have been Jupiter. What Jupiter actually was in those days was a mystery, and it took until Galileo first trained a telescope on it to learn more. But as our understanding of Jupiter as a planet has progressed from there, new mysteries have arisen regarding this world. So here are 10 unusual aspects of planet Jupiter. Number 10. You can hear Jupiter on shortwave radio. Amateur astronomy is usually something we think of in terms of optical telescopes, binoculars, and naked-eye stargazing. But there is another way to do it, radio astronomy, and with the right equipment you can actually listen to Jupiter. Jupiter produces radio waves very strongly at roughly 5 to 40 megahertz. This means that a shortwave radio with the right antenna can pick up Jupiter's emissions. How it creates these radio emissions has to do with the actions of subatomic particles spiraling around in Jupiter's intense magnetic field. Jupiter's emissions tend to sound like distant ocean waves crashing on a shore, along with crackling and pops similar to listening to a bag of popcorn cook in a microwave. To hear them, check out NASA's Radio Jove project, link below for more information. Number 9. The Great Red Spot. One of Jupiter's most prominent features is the Great Red Spot. Astronomers have been observing it continuously since about 1830, but unconfirmed observations of what might have been the red spot go back to the 17th century. It's anyone's guess how old the spot actually is, but even at 2 centuries, it's hard to imagine how a single storm could rage for so long, but it has. But it's also changed across time and may even be dying. In the 21st century, the spot has been observed to be shrinking, and even flaking, with small parts of it spiraling off the edges and dissipating. This could mean that the storm is winding down, but equally possible is that it might flare back up and continue to rage on for centuries. Part of the problem of figuring this out is that we actually know very little about the dynamics of the red spot, or how deeply it extends into Jupiter's atmosphere. There is some indication that material from deep below upwelling into Jupiter's atmosphere is likely playing a large role, but much of it is a mystery still, including its coloration, which ranges from red to a kind of salmon color. Chemically, what's happening to cause the coloration and why it changes is also largely unknown. Number 8. Metallic hydrogen. At the temperatures and pressures present within Jupiter's interior, hydrogen can do something very strange when compared to its normal gaseous self. While it normally does not behave like a metal under normal conditions, under the conditions present at Jupiter, it can take on a form known as metallic hydrogen and behave something like a metal and even become electrically conductive. The metallic hydrogen at Jupiter is thought to extend very deep into the planet's interior and be in a fluid state. Above it would be a layer of hydrogen in its normal liquid state, meaning that much of Jupiter is in a fluid state under intense pressure and heat. One odd property of metallic hydrogen is that it's thought that it may be metastable, meaning that you could take a sample of it out of Jupiter into low pressure and it would remain metallic hydrogen. This may have implications on future technology. Metallic hydrogen is thought to be a superconductor, but at room temperature rather than the very low temperatures as is typical for other superconductors. And if it's in fact metastable, it may turn out to be useful for that purpose. Experiments to create metallic hydrogen here on Earth have reported some unconfirmed successes. Number 7. Jupiter's core may have disappeared. Early in the history of the solar system, it's likely that Jupiter started out as a solid core of rock. In order to attract and collect up so much material from the solar nebula to form the atmosphere, it's likely that this object would have been quite large, on the order of 12 to 40 times more massive than Earth. It's always been assumed that this rocky core still exists at the center of Jupiter. But this may not actually be the case. Recent measurements indicate that Jupiter may have no distinct core at all, or if it does, there isn't a hard boundary between it and the metallic hydrogen. The original material from the core is still there, but rather diffusely mixed in with the metallic hydrogen. This is actually rather strange, since this does not appear to be the case with Saturn, our other gas giant. In contrast, it appears to have something more resembling a solid core than Jupiter has, despite being less massive. Why there's a difference is still a mystery. Number 6. Wind, lightning, and the little red spot. Jupiter's atmosphere is violent and ridden with lightning, very powerful lightning that can be as much as 10 times stronger than it is here on Earth. And this lightning strikes constantly. But one oddity about Jupiter's lightning is that it only strikes near the poles of the planet, with none at the equator. This is thought to be an effect of solar heating, which stabilizes Jupiter's upper atmosphere enough to prevent the convection that would normally produce lightning. The poles do not see this heating, and because of that, they see lightning. In addition to lightning, there are Jupiter's winds. Its wind speeds can exceed 384 miles per hour, nearly double that of the highest wind speeds recorded in hurricanes here on Earth. These speeds on Jupiter were recorded in an odd feature known as the Little Red Spot. This feature began forming in 1998 with the merging of 3 separate white storms. There were subsequently several other mergers with other storms, but in 2005, for reasons unknown, the entire storm turned red. What this means and whether we are seeing the formation of a new Great Red Spot remains to be seen. Number 5. Jupiter may have been key to the genesis of life on Earth, or not. One of the contributing factors to life's genesis on Earth is that after the late heavy bombardment stopped, Earth has experienced a general calm as far as impact events go, allowing life on Earth to flourish. Well, unless you're a dinosaur. That said, while they do periodically happen, of course, it could conceivably be far worse. Conventional thinking has always been that this is due to Jupiter essentially vacuuming up material, thereby protecting the inner solar system. But more recent evidence actually suggests the opposite, that Jupiter and Saturn in tandem tend to toss material at us rather than deflect it. Regardless of whichever is the case, we have actually seen Jupiter eat a comet. In 1993, comet Shoemaker-Levy 9 was determined to have been captured and in orbit of Jupiter. It was subsequently torn apart by the giant planet, and in 1994, multiple chunks of the comet smacked into Jupiter in a line, leaving a series of dark spots on the planet's atmosphere that were even visible in small telescopes for a time. Number 4. Jupiter's massive magnetosphere. Not only is Jupiter the largest planet in the solar system, excepting the Sun's, it has by far the strongest magnetosphere of any object in the solar system. This magnetosphere is thought to be generated by the metallic hydrogen, and is so large that it stretches out to the orbit of Saturn, making it one of the largest natural structures present within the solar system. This leads to an interesting effect on Jupiter. Gigantic auroras glow at the north and south poles, and they are far more powerful than what we see on Earth with our northern and southern lights. Up until recently, Jupiter's auroras were thought to simply be larger versions of Earth's, but this has turned out to not be the case. Instead, it's a secondary type of aurora that only causes a very weak effect here, where electrons are accelerated into the atmosphere via rippling in the magnetic field. Given that Jupiter's magnetic field is so much more powerful, it can accelerate the electrons to much greater effect into the planet's atmosphere. And while Jupiter's auroras never stop and are always on display, unfortunately, if you were in orbit of that planet, you wouldn't see them. They do not radiate in the visible light spectrum. Number 3. Where is Jupiter's water? Jupiter is not just a huge ball of hydrogen and helium. Within its atmospheric makeup are also many other elements, including sulfur, nitrogen, and carbon. In fact, it seems enriched with them when compared to an object like the Sun. How this happened is thought to be due to water freezing and capturing the materials, and as Jupiter formed, it could have ingested large amounts of these enriched ice chunks. So there should be plenty of water in the atmosphere of Jupiter, but there doesn't seem to be, at least in the concentrations expected in order to yield all the other materials present. How the concentrations of other elements present in Jupiter's atmosphere came to be remains a mystery. Number 2. Jupiter's mysterious flashes. Over the past few decades, amateur and professional astronomers have noticed bright, short-lived flashes of light coming from Jupiter. While these are thought to be impacts of large objects, to be seen at a distance, they did not leave the characteristic darkened debris spots that comet Shoemaker-Levy 9 did. As if that weren't enough, Jupiter's belts also have a tendency to disappear occasionally, only to reappear sometime later. Some insights have recently been gained into this phenomenon. It appears that white, frozen ammonia clouds can occasionally obscure the belts, only to dissipate, allowing them to reappear. Number 1. The ice shell moons. While Jupiter itself is unlikely to be habitable to much of anything, its moons are a different story. All 4 of the Galilean moons of Jupiter have been advanced as possibly having had the opportunity for life to arise on them, including Io early in its history. As to Ganymede, Callisto, and of course Europa, liquid water oceans beneath the surface of their ice shells seem strong possibilities for all 3 of these worlds. As such, in principle, they are all 3 candidates for current life. While any life found on these bodies is probably going to be microbial, or at least very simple, life does tend to surprise, so who knows what might lie under those shells of ice. But in particular, one candidate stands out, Europa. That moon may be doing more than simply presenting the conditions that life might be there, but rather maybe hinting directly that it exists. Some have speculated that the cracks in Europa's ice show reddish-brown coloration that might be caused by frozen microorganisms from the ocean below. This led to Brad Dalton of NASA Ames to compare the infrared signature of the colorations with microorganisms that live in hot springs here on Earth. They were a close match. Further work with other bacteria also showed certain similarities. While it's also possible that the colorations are simply caused by salts or minerals, it does give one more reason to check out Europa and see if anything is alive in its oceans. One of the greatest mysteries of the solar system is whether Mars has, or once had, microbial life. We know it was once like Earth, and it seems to hint that it could be an abode of life. So here are 10 indicators that Mars may have had, or may still have, life. Number 10. The Viking experiments. In 1976, NASA successfully launched the Viking 1 and 2 missions on the surface of Mars. One of the experiments on board the landers was the labeled Release experiment, designed to detect Martian microbial life. Essentially, the experiment exposed nutrients to the Martian environment and then looked for any evidence that something was metabolizing it. The experiment returned a positive. This detection has been problematic and controversial ever since. Part of the problem is that other experiments on the lander failed to detect organics. Another part is that the Martian surface is an extremely inhospitable environment. Problem 1 is radiation from the sun, and problem 2 are the presence of chemicals such as perchlorate, which can destroy organic compounds. This reaction would produce chloromethane and dichloromethane as byproducts, and those were apparently detected, opening up the possibility that the detection was real, and the reason that organics were not found was that they were simply destroyed. Whether the Viking landers detected life on the surface of Mars is still an open question. The only way to solve that mystery is to go to Mars and experiment some more. This will no doubt happen in the coming years as the human exploration of Mars becomes a reality. Number 9. Formaldehyde. In 2005, the European Space Agency's Mars Express orbiter detected a rather odd chemical signature in the atmosphere of Mars. It's formaldehyde. We normally think of this chemical as a constituent of embalming fluid and a carcinogen, but there's more to it than that. We see formaldehyde in the universe, and interstellar formaldehyde has been extensively studied within the Milky Way, and for good reason. It's an organic compound. In the case of formaldehyde in the atmosphere of Mars, it's possible that it could be a byproduct of the oxidation of methane. This would suggest that Mars is very geologically active, but we really don't see that it is. Its major volcanoes appear long dead, and what may still be occurring doesn't seem too active. The other option is that it's a byproduct of microbial life, but this is a pretty ambiguous indicator in the end. Number 8. The lichen that could survive on Mars. One of the best ways we have of understanding if there was or is life on Mars is to look at very resilient species of organisms here on Earth, simulate the conditions of Mars, and see if they could survive. While a number of resilient bacteria from Earth have been shown to be able to survive the conditions expected at shallow levels in the soils of Mars, one organism stood out. It was an Antarctic lichen. Known as P. chlorophanom, it survived at temperatures as low as -51 Celsius, low atmospheric pressure like that of Mars, and endured large amounts of radiation during a 34-day experiment. The lichen fared well enough that if it had some protection against radiation, such as living under a rock or in a crack, it might actually be able to survive on the surface of Mars long term in an active state, and in fact, it adapted to the conditions and ramped up photosynthesis as the experiment went on. In other experiments involving lichens, they've shown themselves not only capable of handling Mars, but clinging to life in space itself. Lichens might also survive things like Mars's global dust storms by going into a dormant state, something that some Earth lichens can do on the order of centuries if covered in snow or dust. This one has two implications. Firstly, if Mars ever developed life like this lichen, then that life could still be there, surviving in cracks or beneath rocks. Second, we should be careful with what life we transport to Mars, even accidentally, because some of it could, in principle, survive and contaminate that planet. Number 7. Oil on Mars. One of the strangest possibilities is that if Mars once had, or still has, microbial life, it may be possible that the process that produced crude oil deposits on Earth might also have occurred on Mars. On Earth, crude oil deposits are thought to be produced when marine microorganisms die and become trapped in sedimentary deposits. As this becomes sedimentary rock, heat and pressure converts the material into petroleum. While the origin of petroleum is somewhat controversial, in the case of Mars it might have been possible for oil to form from any microorganisms that were present in the past, or, in an alternate hypothesis, trapped hydrocarbons left over from the formation of the solar system, and have crude oil deposits. In principle, these should be detectable as methane emissions, effectively natural gas, through the geologic exploration of Mars, and, maybe someday, an oil rig. Number 6. The reanimating corpse planet. This is more of a concept than an indicator, though if it were to happen, it would provide a perfect opportunity for observing life on Mars from here on Earth. One of the things that makes the surface of Mars inhospitable to most life as we know it is the high amount of ionizing radiation that reaches the surface. But this changes. Due to Mars's orbital eccentricity and the tilt of its axis, it may be that Mars goes through periods, the most recent being about 450,000 years ago, where dormant surface life on Mars hidden beneath the surface might reanimate and recolonize the surface for a time, a sort of periodic Frankenstein planet that reanimates periodically and resembles its former self. If this is the case, then that dormant life might still be viable and detectable as shallow as 1 meter below the surface. Future missions to Mars might look there and see what they find. Number 5. Martian geysers. Mars's southern polar cap is in a constant state of frosting and defrosting seasonally. Because of this, CO2 and likely water can pressurize beneath the surface and erupt as a geyser, usually in the form of cold fluids mixed with mud. This process happens rather quickly, even by geological standards here on Earth, which makes it very odd for sleepy Mars. Around these geysers, dark spots and channels can be seen that are not well understood. One team has proposed that they represent photosynthesizing microorganisms. The idea is that these microorganisms hibernate while the southern polar cap is in darkness. As the sunlight returns, however, light reaches the ice and the organisms beneath. As they start to photosynthesize, they produce heat and liquid water, which is trapped under the ice and cannot evaporate. The sun then further melts the ice, and the microorganisms appear gray. But as soon as the ice melts completely, they dry out and turn black, creating the dune spots. While this remains a possibility, it could also be something entirely geological that forms the dune spots. Only by going there with a probe will we answer the question definitively. Number 4. Curiosity and complex organics. In the summer of 2018, NASA's Mars Curiosity rover at Gale Crater was studying roughly 3.5 billion-year-old mudstone rocks. Within these rocks, something was seen that hadn't been seen on Mars before. Large concentrations of organic chemicals, essentially the missing organics that the Viking landers had failed to detect. They came in the form of very complex organic molecules thought to have been preserved due to the presence of sulfur. Even stranger, this mix of chemicals resembles what happens when kerogens break down. Kerogens are interesting because they are of biological origin here on Earth, and in fact are a precursor to crude oil. But resembling does not make for a dead ringer, just a hint that life may have been responsible. Number 3. Fossilized bacterial mats on Mars. Life leaves its mark on planet Earth in many ways, ranging from the oxygen in our atmosphere to the fossils of shells one might find eroding from a mountainside. But even the smallest life, the bacteria, do leave traces of themselves. One such trace are fossilized bacterial mats that show the action of bacterial colonies millions of years ago. Here on Earth, these mats form in areas of shallow water, such as lakes or coastal areas. If the mats are undisturbed, they can fossilize, and in fact may represent some of the oldest fossil evidence of life on Earth, with one formation in Australia yielding examples that are as old as 3.48 billion years. But Earth is not the only place where potential fossilized bacterial mats have been seen. There are candidates on Mars photographed by NASA's Curiosity rover. Present are domes, roll-ups, pits, and other indicators in the sedimentary rock that looks much like they do here on Earth. More mats here on Earth change as they dry up, rebound, and so on. This also appears to be the case with the structures on Mars. The rocks look eerily similar. Unfortunately, to go much further with this one, we would need a sample return mission to bring samples of the sedimentary rock back to Earth to be studied in a lab. This is unlikely to happen anytime soon. Number 2. The Martian meteorites. It may surprise you, but we actually have pieces of Mars right here on Earth in the form of meteorites that originated on the surface of that planet, but were blown off into space during large impacts. There are currently over 100 known examples of meteorites that show geologic and chemical evidence indicating a Martian origin. Some of these rocks may indicate the presence of past life on Mars. This is a controversial topic, and no consensus within science has formed around just what's going on with certain features in these meteorites. At one point, it was even announced by then-President Bill Clinton that evidence of life had indeed been detected in the Allen Hills 84001 meteorite. This was called into question by other researchers, but it's an interesting factoid that the only government to have ever announced evidence of the existence of extraterrestrial life in an official capacity was the US government under the auspices of NASA, and they jumped the gun and announced it too early only for it to be called into question. Wrap your minds around that one, conspiracy theorists. The first of these meteorites is the aforementioned Allen Hills 84001. This meteorite was found in Antarctica, and in 1996 it was reported that microscopic features along with geochemical anomalies may indicate evidence for past life in this meteorite. The problem was that this life was very small, far smaller than Earth microbes, and as the story unfolded, it became clear that non-biological processes could explain all of the features seen within the rock. But life could also have been responsible, so the question to this day remains up in the air. Another example is the Nakhla meteorite, which fell in Egypt in 1911. With this meteorite, evidence of what looked like nanobacteria again were found. Further, they found organic chemicals within the meteorite that might be life-related. And they further found that most of it probably isn't recent earthly contamination, but actually from Mars. But carbon is a common element, and you don't need life for it to exist. In fact, it's the opposite in Earth's case with its carbon-based life, so no dead ringer here. Two other meteorites that show anomalies are the Shergati and Yamato 000593 meteorites. Shergati shows what appears to be alteration by water before it arrived on Earth. Fragments of this meteorite were picked up almost immediately by residents of Shergati, India, and it was an observed fall, so this is a very pristine example of a Martian meteorite. Within it, what appears to be a biofilm associated with microbes has been reported, but more work on this meteorite needs to be done before anything conclusive can be said. With Yamato 000593, this meteorite is effectively a lava rock, a basalt that formed on Mars about 1.3 billion years ago. There it sat until about 12 million years ago when it was ejected in an impact. Evidence of exposure to liquid water before it fell to Earth is present in this meteorite, but there are also bizarre spheres of carbon found inside, but only in certain parts of the rock. Biology being responsible for this is on the table, but again, it's far from conclusive evidence. Number 1. Methane. The biggest hint that something life-related may be going on at Mars is the gas methane, which is a gas that life on Earth produces. Mars's atmosphere makes methane chemically unstable. The ultraviolet radiation streaming off the sun and the chemistry of Mars's atmosphere quickly destroys the gas. This means that if methane is present on Mars, it must be replenished by some process, either geological or biological. Methane has indeed been detected on Mars. And the source of that methane is rather mysterious and tantalizing. We're not talking about a lot of methane, which was first detected on Mars in 2003. But as study continued, it became clear that the methane was concentrated in certain areas on Mars, and more provocatively appears to be seasonal. Seasonal methane releases could be produced geologically, but we also know how seasonal changes impact life here on Earth, and the lack of obvious volcanism and hydrothermal energy on Mars would be a point against geology. Bolstering this were observations from June of 2019 by the Curiosity rover, which detected unprecedented levels of methane being released. While it's still not clear if it's biological in origin, it could be that methanogenic bacteria very similar to the earliest life on Earth could still be active on Mars deep below the surface where liquid water is still possible. Once again, only human exploration is likely to answer the question. On this channel, we often wander the universe distantly, at least with our imaginations if not physically going there. But this time, let's look closer to home, but not too close. It's somewhere we've actually visited in person. It's the moon. And like most objects in the universe, it is no stranger to mysteries and oddness. So here are 10 strange aspects of our own moon. Number 10. Human impact on the moon will last a very long time. We live on a very, very dynamic planet. The forces of nature on Earth are constantly at work reshaping our world. Volcanoes deposit new rock. The winds and water erode. Not so on the moon, where erosion, provided by micrometeoroids impacting the surface over immense amounts of time, and to some degree the solar wind, is so slow that any change introduced by human activity will last almost indefinitely. Take this footprint from the Apollo missions. It's estimated that it could last at least several million years at current rates of erosion, or lunar gardening as it's called. But the equipment itself, such as the descent stage, could last up to 100 million years. That's if a bigger meteorite doesn't come along and entirely obliterate a landing site. But there is one type of object left on the moon that is almost certainly no longer there. It's the American flags. Due to the intense ultraviolet radiation from the sun, Earth has some protection there and things still fade and degrade. The moon has no protection at all, and the nylon flags would have completely degraded and disintegrated over the decades. By now, nothing likely remains other than the poles. Number 9. The moon has a smell. During the Apollo missions to the moon, it was noted by the astronauts that the moon's dust was not easy stuff to deal with. No matter how well they tried to brush off their suits before going back into the lander, they could not eliminate the lunar dust that clung to them. Upon getting back into the lander and taking off their helmets, they noticed that the lunar dust smelled very strongly. Described as smelling something like spent gunpowder, the reason for this smell remains a mystery because gunpowder and the lunar dust have very different compositions. Ideas include ions from the solar wind, along with the very dry lunar dust coming into contact with humidity, creating the odor. Presumably this will be an issue for any lunar colony we've found, and I would imagine good air filtration will be a must. But there's another aspect to this. Astronaut Jack Schmitt even had some kind of an allergic reaction to the dust the first time he smelled it, though he acclimatized in later incidents. Number 8. The moon may have water and sparks. The lunar surface is a very, very dry place. Desert doesn't describe how dry it actually is. Water does not survive on the surface long term due to the action of the intense sunlight. But there are areas on the moon where sunlight never reaches. In the 1960s, it was first conjectured that certain craters on the moon, near the poles, that were deep enough to never receive any sunlight, thus could still contain water ice, deposited there long ago by comets. Evidence mounts that this is indeed the case, with NASA's Lunar Reconnaissance Orbiter discovering that the floor of Shackleton Crater near the moon's south pole could have as much as 22% of its surface covered in ice. This is important for any hopes of founding a human colony on the moon. Water is heavy, and launching it from Earth is expensive, so having as much water natively available to a colony is a great thing, not only for drinking and growing food, but also making oxygen and fuel. That's one less problem facing those with the intent of colonizing the moon. But that's not the only thing to be found in the permanently shadowed regions of the moon. Scientists have found that the soil in these regions show evidence that it has been partially melted. That's not too surprising for a surface being bombarded by micrometeoroids, but there may be something else going on here melting the soil. A recent NASA study found that during powerful solar storms, the moon's surface might become electrically charged in the very cold, permanently shadowed polar regions. That charge would build up over time and then discharge, causing the soil to literally spark and slightly melt. Imagine how alien that might seem, walking on the lunar surface in pitch black conditions, the only sources of light being the stars blazing overhead with no atmosphere or light pollution to mute them, and tiny flashes from the sparking soil beneath your feet. Number 7. The moon may have once been part of Earth. A great mystery within planetary science is just how the moon formed. The best explanation yet, though not universally accepted in the scientific community, is that early in the Earth's history, so early it's best to call it Proto-Earth at that point, a Mars-sized object impacted Proto-Earth and blew out the materials that would become the moon into space. Given the name Theia, this Mars-sized object is thought to have been a glancing blow where it hit at a certain angle sufficient to toss enough material out of the collision that could coalesce and become the moon. This is backed up with chemical similarities between the moon and Earth's geology, which is not consistent with objects that formed in different areas of the solar nebula. But this creates a problem. The moon is responsible for Earth's tides. That in turn is suspected to have played a role in the genesis of life on Earth. Tidal pools are a possibility for the solvent where the chemistry of life first occurred. So if the moon hadn't existed, then tidal pools couldn't have occurred as described. So are we here because of the existence of the moon? And does that apply to the rest of the universe? If terrestrial planets like Earth do not have moons, can they host life? Unknown. But if that's the case, and the natural chemical laboratory for the genesis of life relies on the existence of a terrestrial planet with a large moon, then how often does that happen? We don't know. But Mars has only tiny, inconsequential moons. Mercury's got nothing, and Venus, which is effectively Earth's twin, also has nothing. Does this mean that terrestrial planets within the inner parts of star systems don't form moons unless an accident happens like a glancing blow? We do not yet know the answer to that question, but it could solve the Fermi paradox in coming years as we figure out what the deal is with Earth-like planets and exomoons. Number 6. Moonquakes. We always think of the moon's tidal effects on Earth as a phenomenon of our ocean that's caused by the moon, but only affects us. But it's very much a two-way street. Earth too has tidal effects on the moon, and it causes one major effect: moonquakes. During the Apollo missions, the astronauts set up seismometers on the moon. This was essentially to see if there was anything happening, but expectations of the time were that they might not pick anything up, and moonquakes do not occur regularly. This is because the moon does not have plate tectonics, which is one of the main driving forces behind earthquakes on Earth. But the seismometers did pick up moonquakes, and there were several different types. One obvious cause were those created by meteorite impacts. Another type were thermal in nature. As the crust of the moon contracts and expands when sunlight is either present or isn't, then small quakes occur. But very deep quakes were also found, as much as 700 kilometers below the surface. These appear to be created by Earth's tidal forces acting on the moon. As our planet pulls on the moon, it has to adjust, and when it does, it creates moonquakes. These quakes are significantly weaker than what we experience on Earth, but the final type detected by the Apollo missions is a bit more mysterious in origin and a bit more powerful. These were shallow moonquakes. The cause of these more powerful moonquakes is still a mystery, but it may involve movement in fracture zones in the rock underlying the surface of the moon. Only more study and more seismometers on the moon will shed light on these more powerful moonquakes. Number 5. Why is the far side of the moon so different from the face that we see? The moon is tidally locked to Earth and always presents the same face to us. In fact, until 1959, when the Soviets sent a probe, no human had ever seen the far side of the moon. Before then, it had been expected that we could reasonably assume that the far side would look much like the part that we see. This was most certainly not the case. The near side of the moon is covered in dark regions, the familiar lunar maria that we look up at in the night sky. The far side is nearly devoid of these, instead showing a dramatically mountainous and cratered surface. And it's not just visually different. It's been found that the moon's crust on the far side is apparently significantly thicker than on the near side. The reason for this is not known, but it does explain the differences between the near and far side. The thinner side was simply more prone to allow for molten mantle material from the moon to flow out after an impact, forming the maria. But it doesn't answer the question as to why the far side's crust is so thick. One possibility is that when the moon formed after the collision with Theia, the coalescing material may have formed two moons, a large one and a small one, in a similar orbit. At some point, they collided, but not in a huge explosive event, but rather something like a slow splash, where the object basically flowed out onto the far side of the moon, causing the thicker crust on one side. But there's a problem. If this is what happened, we would expect to find differences in composition on either side of the moon. We don't. The variations within the composition of the lunar surface appear continuous between both sides. A second idea is particularly interesting to imagine. After the formation of the moon after the impact with Theia, the moon could have been seriously close as 20,000 kilometers, and both Earth and the moon would have been in a molten or semi-molten state at this time. Given how close they were, the tidal effects on both bodies would have been severe. During this time, the tidal locking of the moon might have occurred, with the near side facing a very hot Earth and the far side cooling far faster. This could have allowed vaporized materials to migrate to the cooler far side of the moon and condense and building up a thicker crust over time. Number 4. The moon is receding into space. While the moon was once closer to Earth, the process of it receding has never stopped, and each year the moon moves about 4 centimeters further away. This leads to an odd coincidence that the moon's apparent size in the sky is nearly identical to the sun. It allows for total solar eclipses and a nearly complete view of the sun's corona. This is rare. While eclipsing bodies in the solar system aren't rare, it's rare that our moon can so exactly block the sun's disk. This was not always so, and in 600 million years it won't be possible, and only annular eclipses will be visible from Earth. As the moon moves further away, things are eventually going to get chaotic here on Earth. Sometime around 3 billion years from now, it will be so distant that it no longer regulates Earth's rotation. This means that Earth will undergo serious changes in its axial tilt, and the whole thing will become highly irregular. But at least it's better than what's going to happen with Mars. Its moon Phobos is set to collide with Mars in only about 50 million years. It's too small to destroy Mars, but if we have colonies there at the time, it'll be a problem to tackle for sure. Number 3. Without the moon, we may have never evolved. One of the biggest questions within the subject of the origin of life on Earth is the role of the moon. One possibility is that life first arose here in oceanic tidal pools. Water accumulates in a pool, essentially becomes stagnant, and that allows for the chemistry of the beginnings of life to occur. If this is the case, then the moon causes the tides, and without it, life on Earth might not have been able to arise. While speculative, the actual conditions for which life to come from abiotic chemistry are poorly understood at best, and there are ways for water to pool other than tides. It does raise an interesting possibility. If indeed a large moon around a terrestrial planet is required for life to arise, then look at the inner solar system. Venus has no moon, and Mars just has very tiny ones. It would mean that they had no chance for life, and Earth only had it because of a chance collision with a Mars-sized object. Therein is a question: do large moons indeed form around terrestrial planets in most circumstances? We've never seen that with exoplanets. Small planets like Earth are very difficult to detect, and even smaller moons around them even less so. So it may be that we live in a very unusual system. The Earth-Moon arrangement may be quite rare in the universe, and if it turns out that this arrangement is a requirement for life to arise, then we live in a very lifeless universe. But again, that's speculation. We don't know. But it's certainly ominous as far as life in the universe is concerned. Number 2, the end of the moon. The slow estrangement from our moon as it spirals out has a happy ending of sorts. The moon's attempted escape faces an insurmountable problem. That is the sun's evolution to become a red giant. As it does so in the far future, at some point during the expansion, the gases from the sun will cause drag on the moon and cause it to start falling in towards Earth again. As it approaches closer, it will hit the Roche limit, which means that the gravitational forces holding the moon together will be overcome by the tidal forces of Earth. This means that the moon will predecease Earth and be torn apart to form a ring system. The dying Earth, for a time, will resemble Saturn as it is today, but not for long. This ring will fall to Earth, and then eventually Earth itself will be consumed by the sun, and that will be it. Or will it? Other models suggest that the moon might actually be tossed away from Earth, with Earth being destroyed, and then spend its lonely eternity without its former companion. Or it could be that the Earth and Moon system isn't consumed at all. The process of a star losing mass as it swells to a red giant stage isn't well understood, so it might be that the scorched Earth and Moon will spend eternity together, much as they are now, orbiting, in a probably very changed way, a cooling white dwarf cinder remnant of the Sun. Number 1. The Moon is being bombarded by life. Orbiting a planet with an enormous biosphere and even a civilization living on it is going to expose a moon to life in a number of ways. Most obviously is when that civilization lands on its surface and plants a flag on it. But that's not the only way life from Earth could end up on the moon. Now, ending up on the moon and living on it are two different things. The moon is far too harsh for anything to survive there for long. But just as meteorites of lunar origin are found here on Earth, it may also be the case that rocks from Earth have transported life to the moon through panspermia. It's safe to say that that life didn't last long, but it's possible that even tardigrades, which are not microbial, might have made it to the moon in some form. And of course, traveling with Apollo would have been bacteria, even within the astronauts themselves in their intestinal tracts. But humans aren't the only macroscopic life from Earth to have been to the moon. There's another seemingly unlikely visitor to the moon that greatly outnumbers the number of humans that have visited the moon. And if you know where to find one, you can meet one of these alternative astronauts yourself and even talk to it for hours if you're so inclined. It's a group of trees. During the Apollo 14 mission, astronaut Stuart Roosa used his small amount of space allotted to carry personal items to carry tree seeds. Roosa had once been involved with the U.S. Forest Service in suppressing wildfires and wanted to pay tribute to the U.S. Forest Service. What better way than to bring along some seeds? And there was science to this. Scientists used the opportunity to see what would happen to the seeds after being on the moon. Turns out the seeds were resilient and most of them germinated, and the seedlings were distributed, and cuttings were made and also distributed, meaning that there are a lot of moon trees out there. Unfortunately, the record keeping was poor, so for the most part we don't actually know where most of the moon trees are currently located. Efforts are ongoing to find the moon trees. Many of them have plaques from when the trees were distributed in the 1970s, but some of them will never be known and could be anywhere. Known examples are growing at Goddard Space Flight Center and a Girl Scout camp in Indiana, and trees are generally long-lived. For example, some of the redwood trees from the experiment could live for centuries. Perhaps their seeds will be brought back to the moon in a new round of exploration. If we're ever going to explore and eventually colonize the galaxy, we're going to need functioning propulsion systems to do it. This goes for the nearest star or the other side of the Milky Way. So here are 10 hypothetical interstellar propulsion systems we might someday use to travel interstellar space. Number 10. Light sails. Light sails at their simplest are sails that function not on wind but on light pressure. Lasers stationed on Earth or in space can exert pressure on sails. Sails in general are ancient ideas, and we have lasers. So out of all of the entries on this list, we are closest to realizing this one. In fact, there are multiple programs looking to build and use laser-driven light sails, including Breakthrough Starshot, which looks to send a swarm of microprobes attached to light sails to Alpha Centauri at as much as 20% of the speed of light and get them there in just 2 to 3 decades. However, scaling this up to manned capability presents significant challenges, but as a means of exploring nearby stars, if programs like Breakthrough Starshot are successful, interstellar exploration may begin within the lifetimes of people alive today. Though one could argue we're already doing that, using instruments from Voyager to study the conditions of the fringes of the interstellar medium. Number 9. Nuclear pulse propulsion. Over the decades, there have been several proposals to build spacecraft accelerated by nuclear detonations to reach high enough speeds for realistic interstellar travel. The concept is simple. Build a spacecraft with a blast shield at the back and then periodically drop nuclear bombs out the back of the ship, detonate them, and that in turn pushes the spacecraft along. Increasing public distaste for nuclear projects and nuclear test bans sidelined work in the field of nuclear pulse propulsion, but it does provide us with a future means of interstellar travel. And nuclear detonations in space aren't the problem that they are here on Earth. Space is already full of sources of radiation. The launching materials off Earth to fuel such a spacecraft does pose risk, as is often pointed out when NASA launches radioactive isotope-powered probes such as the Curiosity rover. This type of propulsion is, in principle, something that our current technology is close to being able to do. Number 8. Starseed. This option is effectively a nanoprobe gun. Using a 1,000-kilometer-long hollow tube lined with electrodes, exploratory nanomachines could then be electrostatically launched at very high speed, up to 1/3 of the speed of light. This puts a one-way trip to the Alpha Centauri system at roughly 13.5 years. That's fast, and the main advantage is that researchers sending these kinds of probes would get to see the fruits of their research within their lifetime. There are 2 downsides to this method, however. Number 1 would be the tube itself. Given its length, the tube would be difficult to keep straight and would need to be kept well away from gravitational sources in space to keep the nanomachines from impacting the tube while being accelerated. It's likely that the materials needed to create this are yet to be fully developed. The other issue is that nanotechnology is still generally in its infancy, so this method lays at least decades off. But one can also imagine many types of hypothetical nanoprobes, such as modular devices that assemble into a larger probe upon reaching their destination, or von Neumann probes that can self-replicate on-site, or build custom equipment without having to return to Earth. How far this scales up, or if this could ever be used to do more, such as custom 3D print out humans on site to colonize a planet, remains to be seen in the relatively far future. Number 7. No-hurry propulsion and Dyson slingshot. As it stands at currently attainable speeds, it would take our current rocket-based technologies centuries to get to the nearest star system. Voyager 2, for example, will need 42,000 years before it will come close to another star, and it's only 10 light-years away. But over vast amounts of time, hundreds of thousands to millions of years, the galaxy shrinks and can be fully colonized in terms of a few million years at slower speeds. If you have that kind of time, or you're in a situation such as a multi-generational ship built, say, from an asteroid, then slower methods can be used. Other possibilities include powerful rockets launched not from Earth but from space, and also gravitational slingshotting. But if you chose your destination wisely, you can do much more with this than you might think. The concept of Dyson's slingshot comes into play. If you can get to a certain type of binary system, such as closely orbiting white dwarfs or even binary neutron stars, these types of systems can be moving very rapidly. Some of that energy can be imparted to a spacecraft passing close by and slingshotted out on a new trajectory at much higher relativistic speeds. In other words, it may take you a while to get to a binary neutron star system, but once you're there, you're on your way much faster to wherever you wish to go. Number 6. Nuclear fusion drives. Fusion always seems to be right around the corner, and has been for decades, but recent developments may be changing that status quo. While large fusion reactors like what might be developed from megaprojects like ITER wouldn't seem useful in space until decades at least from now, there is a lesser-known, somewhat more secretive project that may yield results much sooner. It's the compact or high-beta fusion reactor being developed by Lockheed Martin's Skunk Works. If that project works out, fusion could not just finally be right around the corner, but the reactor would be small enough to launch into space. If that ends up being the case, and if the idea works, that would allow energy generation in space on unheard of scales. The International Space Station, for example, has about 75 to 90 kilowatts available to it, generated by an acre of solar panels. High-beta fusion reactors would produce 100 or more megawatts, enough to run a large city, yet be about the size of a city bus. With that kind of power available, goodbye ISS, hello Battlestar Galactica. There are several ways to use fusion as a propulsion system. One is direct thrust created by the fusion reaction, and another would be to generate electricity for the various electric methods of producing thrust, such as ion drives, plasma drives, photonic drives, and so on. Number 5. The antimatter Valkyrie. Imagine being able to travel at 92% of the speed of light, and then when you need it, have the means to slow back down. And unlike some hypothetical faster-than-light methods of propulsion using exotic forms of matter, this one can be done with a material we've already created here on Earth, though it's perhaps the most costly material on Earth to produce: antimatter. Assuming that antimatter in the future can be created in sufficient quantities efficiently enough to make it worth it, you could build the Valkyrie. How this works is that you create a small matter-antimatter reaction, and the exhaust from their total annihilation pushes you along. Then, you add more antimatter, on the order of 100 tons or so for the length of your trip, and in the process, you've reached some seriously relativistic speeds. As designed, the Valkyrie works more like a train of sorts, with the crew compartments and payloads suspended between two engines on a long tether, which has the effect of reducing the overall mass needed to build the ship by eliminating some of the radiation shielding needed, as the engines would produce gamma radiation. At these speeds, dust and debris in the interstellar medium would be a problem. Shielding from space debris is accomplished in this design by a dual-use radiator in front of the ship. Droplets of liquid heated by waste heat are sprayed in front of the ship, then they fall back down, cooled back into the radiator for recycling, and the cloud of liquid in front of the ship has the effect of shielding. Unfortunately, the biggest problem with this design is the uncertainty over whether we could ever find a way to manufacture antimatter on a large scale. Tons would be needed, and it's currently only available in seriously minute quantities. Then you have to contain the antimatter, which is quite hard. New technologies would be needed, and until that changes, if ever, this method cannot be pursued. Number 4. The Alcubierre Star Drive. This option has been thought about for a while, and if it's possible, it would allow not only interstellar propulsion, but intergalactic propulsion, faster-than-light travel, and shielding from the relativistic effects of traveling at high speed through the normal universe. The idea is that you circumvent the speed of light limit by effectively splitting off a piece of space-time around your spacecraft and accelerating it, and by proxy your ship, to faster-than-light speeds. The ship itself is actually not moving through space-time. It's sitting stationary on a piece of space-time that is moving. This is possible because space-time itself is not subject to the faster-than-light ban, and can, in principle, be made to propagate through the universe far faster than light. However, this option suffers from a bunch of problems people have thought of over the years. One of them is that you would need some serious energy to get it going, perhaps prohibitively so for most civilizations. But more recent thinking is shrinking this amount of energy further and further. Another issue is that you'd need negative matter, which is something that the universe does not prohibit from existing, but that's it. So it's not banned, but we have no clue how to make it, and there's no evidence that any of it exists naturally in our universe. Other problems include surviving the trip, which again, as discussion of the concept has progressed, problems have seemingly cropped up. But if it turns out possible, then warp engines from Star Trek will seem like bicycles in comparison to the Alcubierre drive. There doesn't appear to be a hard and fast upper speed limit for the drive, but there's also no guarantee you could figure out a way to slow it back down, but it would allow access to at least large swaths of the universe. Number 3. Black hole starships. Intuitively, we might think that black holes are by their very nature inherently dangerous, and they are in certain situations, such as if you're falling into one. But they are also incredible objects that could, under the right circumstances, make for good propulsion systems. But in that case, you wouldn't want to use a natural black hole. Instead, you'd want to make an artificial one, and they are possible to make. Once you had a black hole, then you would use its Hawking radiation to propel the ship, essentially by creating a dish and directing the radiation. The materials needed to shield gamma radiation and build such a ship, it would generate a lot of heat, do not yet exist. But if they did, a 606 metric ton artificial black hole could produce 160 petawatts of energy. With that available energy, you could reach relativistic speeds in a matter of days. It's still being debated in physics whether using a black hole to power a starship is actually possible in practice, but it's not the only way you could use an astrophysical object to generate thrust. You can also use stars. This idea is relatively simple. Called a Shkadov thruster, it essentially involves building half a Dyson sphere, which then directs the star's output in one direction, thusly moving the star itself along with the thruster. At least initially, this is not a fast way to travel, it would take time, but a civilization that has nothing but time on their hands might employ the Shkadov thruster as a long-term star management system, moving them around to wherever they might wish. Number 2. Traversable wormholes. The concept of a possible connection or tunnel to another part of the universe is an alluring one in science fiction because it's one of the few ways that the speed of light limit might be circumvented that's consistent with general relativity. It's the traversable wormhole, and while entirely hypothetical, there are objects in nature that may or may not actually be hosting wormholes, such as the singularity at the center of a black hole, or very tiny ones that form in the quantum foam. The problem with wormholes is that they don't really appear to be very traversable, but what could make them traversable is, once again, negative matter. A shell of negative matter might be able to hold a wormhole open, but it's somewhat unclear where you might end up. Would it take you to some other point in the universe? If so, what time period, as they also open up the possibility of time travel. In fact, Kip Thorne and colleagues advanced that a wormhole normally connecting 2 points in space could be turned into a time machine if you accelerate one of the openings, though you could never go back to a time before the wormhole existed. But there's another aspect. If you could somehow open a wormhole and hold it open and step through, you may not get what you expect. One last possibility for wormholes is that they might not lead to some other point in space-time, but rather an entirely different universe. This is a problem because if other universes exist, they may have very different properties than this one, so stepping into a universe where matter can't exist in the form it does here, you may simply dissolve. Number 1. The Halo Drive. This option is a very recent addition to the list of possible star drives. In a recent paper by David Kipping, linked below, and links to an in-depth video he did on the subject, and a recent interview I did with him on Event Horizon, he proposes using binary black holes as a method of propulsion. To make it work, you would fire a laser at the event horizon of one of the black holes just slightly above the surface. The gravity of the black hole would then warp the laser around to the other side, sending the beam back your way, but having increased the energy of the beam, blue shifting the light. This more energetic light could then be used for propulsion at relativistic speeds. This is a very efficient way to do it, since the only energy you need to invest in it is actually getting to the black hole itself. Once past that, the Halo Drive is effectively a free lunch. Also possible here is a method for slowing back down. If you travel from one set of binary black holes to another binary black hole system, you could use the Halo Drive in reverse to slow back down. This could allow for a network of binary black holes to serve as a sort of natural highway system throughout the Milky Way.
It's not over yet. Join me as we continue to travel through the cosmos.
One of the great gray areas of astrobiology is just how alien biochemistry might work. Conventional wisdom would be to look at life on Earth. We know for a fact it can exist. And then imagine how that might apply to life in the universe. And while there doesn't seem to be any reason to doubt that carbon-based biochemistry couldn't be common in the universe, it's also possible that other types of radically different biochemistry could exist. So here are 10 ways alien life could be radically different from that of Earth. Number 10. Alternative chirality. One odd aspect of life on planet Earth is that everything is apparently of one variety when it comes to chirality, effectively how biomolecules can exist in mirror configurations. But there doesn't appear to be any good reason why life couldn't also function in alternative chirality, and that examples of it just happen to be missing here on Earth. Or, at least appears to be missing, as amino acids of opposite chirality have been found here. And while they are thought to be a product of the decay of normal organisms, it also can't be ruled out that life of opposite chirality does indeed exist here and we simply haven't detected it yet. Given what we know, it could be possible that life on other worlds might be based on some configuration of alternate chirality. While different in a chemical sense, these types of configurations wouldn't be all that alien, at least in the sense of it being markedly different from what we see on Earth. In short, we would recognize it as life, but it would be alien in the sense that it would have no relation to life on this world so far as we know. Number 9. Different solvents. We often discuss the search for life in the universe on the presence of liquid water on the surface of an exoplanet. There's a reason for this. It's crucial to life here on Earth. But our planet is a sampling of one. But water isn't the only liquid that life might use as a solvent, and we have to be careful of water bias when evaluating the possibilities for life. Perhaps the strongest alternative to water would be ammonia. Like water, there is no shortage of it in the universe. Ammonia can support a wide range of chemical reactions and can dissolve organics. Other possible alternatives to water include formamide, hydrogen fluoride, and even hydrocarbons, opening the way up for very low temperature life. And also liquid in low temperatures is nitrogen. But as with anything, there are trade-offs, and the alternate solvents seem more limited for life than liquid water. But water actually does have some disadvantages, one being that it has a very high albedo when frozen, contributing to the severity of Earth's ice ages. Also possible are a few possible mixes of water and other liquids, such as ammonia and water. This is thought to be possible at Saturn's moon Titan, where a subsurface mix of ammonia and water could remain liquid at much lower temperatures than water alone. The solvent in which alien life is based would also profoundly affect things like evolution. For example, water being transparent to sunlight helped guide the evolution of oceanic creatures, and ultimately the formation of eyes. In other conditions, in other fluids, the equations can change, and life based in an alternative solvent could end up being very different from that of Earth indeed. Number 8. Arsenic life. Even though arsenic is usually considered poisonous, at least to humans, it's thought that phosphorus and arsenic are chemically similar enough that it may be possible that alien life could use arsenic in its biochemistry and even its DNA. And arsenic might figure prominently as far as life in the universe at large, because phosphorus has somewhat of a problem. Astronomers studying the abundance of phosphorus in the universe have found that it's actually not that common, due to differences in how it's created in supernovas. If this is the case, life, at least as we know it on Earth, wouldn't be able to get started in some areas of the universe just from a lack of phosphorus. This is enough of a problem that the idea of phosphorus simply being rare and unevenly distributed in the galaxy could be a solution to the Fermi paradox. While contentious, if arsenic can indeed function similarly to phosphorus in biochemistry, then there may well be more arsenic-based life out there than phosphorus-based life. Number 7. Non-green photosynthesis. Plant life on Earth is predominantly green in color due to the plant's inability to absorb some of the green wavelengths of light. Yet, the sun emits strongly in green light. Rather, plants tend to absorb red and blue light. It could be that green isn't absorbed simply because the plant has all the light it needs, at least those on land. But when you start looking at the classes of stars that might also be suitable for alien life, the profiles of their light emissions change. As a result, photosynthesizing plant analogs on exoplanets may not tend towards green, rather yellow, red, or even black. It's also possible that alien photosynthesizing analogs might not even be based on chlorophyll, but rather retinol. If so, this kind of life would appear purple. Number 6. Azotosomes. It's possible, perhaps even likely, that the very simplest microbial forms of life in the universe will tend to look a lot alike, no matter where it's found. Some very likely will be similar to organisms present on Earth, but looks can be deceiving. If functionally similar, their biochemistry could be radically different. Take Titan, the only other body in the solar system to sport large amounts of liquids on its surface, other than Earth, that could support some kind of biology. The problem being, Titan also happens to be extremely cold, far colder than anything life on Earth can withstand. But what of a different configuration of microbial life? Researchers envisioned what this might look like by thinking about different kinds of chemistry, in this case nitrogen compounds that could be used to create a kind of cell membrane that could function on Titan. Called an azotosome, this hypothetical cell membrane could function at temperatures where methane is liquid, about 292 degrees below Fahrenheit. Such a microbe could use the nitrogen, carbon, and hydrogen that are present on Titan in its biology and use no oxygen at all. Number 5. The long sleep. With planet Earth, we essentially got lucky as far as stable climate conditions. Mostly. Our planet undergoes seasonal changes that make certain periods harder on some animal life than the rest of the year. But this could actually get much worse on exoplanets, where life, at least as we envision it, might come to a near standstill for long periods of time. Life on Earth has proven resilient to cold periods. For example, there are species that can completely dry out, freeze, and then effectively come back to life when conditions allow for it. Essentially, this isn't just dormancy, but a period of death and resurrection, and it's not just simple life. There are species of frog that can do this. As to what's possible elsewhere in the universe, there may even be intelligent species that have evolved in harsher conditions than Earth that hibernate, or even outright die in order to survive periods of adverse conditions, only to rehydrate when times get better and effectively come back to life. Such a species might even use that to their advantage, making long journeys across space in a state of natural suspended animation, or even temporary death. Number 4. Silicon-based life. Most elements on the periodic table are not good candidates for life due to their chemistry. An element like gold, for example, doesn't have the ability to react with other elements to create the complex chemistry needed to sustain an analog of biology. But there are a few that might, and chief among these is silicon. Silicon is in the same group as carbon on the periodic table and can form complex molecules that could conceivably be a basis for life. But it's much more limited than carbon is. But on the other hand, it's been suggested that silicones could be more stable than hydrocarbons in atmospheres rich in sulfuric acid, such as Venus-like worlds. And while carbon is extremely common in the universe, more so than silicon, terrestrial planets like Earth are very rich in silicon, yet poorer in carbon. Yet, despite that, life on Earth is carbon-based, and we have not found any strictly silicon-based life on this world, though plenty of life uses it, such as diatoms. And one hypothesis holds that the presence of silicon may have been necessary for carbon-based life to have its genesis. Silicon-based life might also be well adapted for very low temperatures, or high ones. And it has to be said that it may be the case that silicon ends up being the basis for intelligent life, not in a biological context, but a technological one, as a species may choose to transition to become a machine civilization. But silicon isn't the only possibility. Boron-based life is also in principle thought possible, though it's somewhat rare in the universe. Sulfur also has hypothetical scenarios where life based on it might be possible, but perhaps most interestingly are some of the metals. Life might also, under very strict conditions, exist using metal oxidation, even at very high temperatures where carbon-based life probably cannot exist. Number 3. Neutron star life. One of the biggest problems when discussing the possibilities of alien life are biases. Carl Sagan once said that he was a carbon chauvinist, and to a degree a water chauvinist when speculating about what alien life could be like. But it could also be surprising, and nothing like what we're used to. One possibility, though a long shot, would be life based on a neutron star. First proposed by Frank Drake and explored in the books of Robert Forward, this highly speculative form of life would exist on the surface of a neutron star. They would be very tiny, submicroscopic, existing based on a kind of alternate type of molecule where tightly packed atomic nuclei form random molecules of sorts. It's a complete unknown if this is even possible. Neutron stars are made up of extraordinarily dense material. But what can be said is that if this type of life does indeed exist, it might exist in fast forward due to the speed at which nuclear reactions occur. They would experience their lives conceivably millions of times faster than you do. Number 2. Plasma life. So far, we've taken the subject of alternative life mostly from the standpoint of straightforward chemistry, but that may not be the only possibility for life. In 2003, researchers were able to create plasmas that exhibited lifelike behavior in that they could grow, replicate, and even communicate to some degree with each other. This plasma phenomenon featured a distinct layer, much like a cell wall, that separated it from its outside environment, a key feature of biological cells. They could also replicate by splitting in two, again like living cells, and they demonstrated the ability to grow under certain circumstances. The communication came in the form of electromagnetic emissions. If this indeed can be considered a form of life, which is fully open for debate, we may have already seen an alternative form of life. Number 1. The shadow biosphere and RNA life. While speculative, the concept of panspermia, the idea that life could hitch a ride on rocks blasted off a planet and then fall on another planet and survive it to colonize, isn't all that far-fetched and may well have occurred within our own solar system. Indeed, life on Earth might have originally been seeded here from some other body, such as Mars, where conditions in the past may have made it an easier place for life to arise than Earth was at the time. But the idea of panspermia can be extended to interstellar scales. While carbon-based life as we know it may not have the greatest chances of surviving interstellar travel, it's possible that some of the hypothetical alternative life on this list might fare better, such as silicon-based life. If this is indeed possible, it might be here undetected, or if silicon-based simple indigenous life could have formed on Earth, then would we even know about it? The answer is not necessarily. The shadow biosphere is a hypothesized second biosphere, or even a second separate genesis of life on Earth based on some other biochemistry. Given that our methods of studying microbial life typically depend in some way on familiar means of biochemistry, it's possible that an entirely different microbial world could, at least in principle, exist alongside our standard microbial biosphere undetected. Another variant on this theme is that it's possible that there were once organisms on Earth that may have been based on RNA instead of DNA. If so, the methods typically used to detect microorganisms wouldn't detect them, should they still be living among us. While the shadow biosphere is hypothetical, there is a phenomenon in geology known as desert varnish that's not well understood. It forms as deposits on the surface of rocks, and its origin is more likely to be geological rather than biological. But one odd feature of this material is that it's very high in manganese, about 50 times more abundant than is normal for Earth's crust. One possibility that's been advanced is that a shadow microorganism could be depositing it. The universe is a very strange place, full of mysteries and odd possibilities that, while scientists ceaselessly try to figure them out, may remain complete unknowns forever, no matter how advanced our civilization and our science becomes. So here are 10 bizarre possibilities regarding the universe that we may never understand. Number 10. We may never know what gravity is. One of the biggest mysteries in science is the nature of gravity. For something that we interact with constantly, we really don't know that much about it. Newton tried to tackle the issue, but only came up with a general way of expressing how it behaves, but not what it is. And even then, Newton was very slightly off. Einstein took that further, but he himself spent his last decades trying to figure out just what gravity is, but again, to no avail. Today, scientists know how gravity behaves in the framework of space-time and can predict it very accurately, but what the force itself actually is remains an unknown. Ideas on this range from the existence of an elementary particle known as the graviton that mediates the force of gravity. Trouble is, gravitons have never been found, and there is doubt that they even exist. Another take on it is how Einstein described gravity, as a warp in space-time, or an inherent acceleration towards massive objects. Trouble is, this is an incomplete view, and again simply describes how it behaves, not what it is. Perhaps the most strange aspect of gravity is that as far as a force of nature goes, it's incredibly, incredibly weak. Look around you. Just to hold you to the ground, you need the entire mass of planet Earth to generate enough gravity to do it. Yet we routinely defeat the force of gravity when we launch space probes. Why it's so weak adds to the mystery, and recent work to determine if gravity is weak because it's mostly leaking into other dimensions came up negative. So gravity remains a great mystery, and while we may someday understand its nature completely, there's also a chance that we never will. Number 9. Is the universe infinite? We live in a sort of bubble within the universe. We call it the observable universe, and beyond it lies more of the universe that we can't observe. This is a matter of the speed of light. Objects beyond a certain point cannot be seen because the universe hasn't existed long enough for the light for them to reach us. One open question within cosmology is how much more universe there is beyond what we can see. Some think it's not that much, yet others think it could be substantial. But there is another idea, that it is infinite, and if that's the case, it introduces some very strange possibilities. In an infinite universe, it becomes plausible that if you travel far enough, you will run into another Earth, slightly different, with another you living on it. Still further, you may find another, again slightly different, and so on, leading to a kind of physical, real, alternate reality, all existing within the same universe. Given that we will never be able to observe the entire universe due to the expansion of the universe, this question may forever remain open. Number 8. The double-slit experiment. This strange aspect of our universe is one of those kinds of things that makes sense when expressed in the mathematical terms of physics, but appears counterintuitive to a human. But the double-slit experiment always yields the same result, having been performed thousands of times. It has to do with the dual nature of particles as both waves and particles. The idea is that you fire particles, say electrons, at a baffle with two slits cut into it. Behind the baffle is a wall. You will see on the wall as the electrons pass through the slits an interference pattern, indicating that the particle is behaving as a wave, much like an ocean wave passing under a pier. However, when you put detectors on the other side of the baffle and observe the particles, the interference pattern on the wall disappears and becomes two slits, indicating that the particle is acting as a particle, not a wave. In short, for all intents and purposes, the act of merely observing it changes the outcome of the experiment. We may never fully understand why this is. Number 7. Will the universe someday cease to exist? A great unknown within cosmology is what's eventually going to happen to the universe. In one view, it will simply go on forever until literally all stars burn out, black holes evaporate, iron stars form, and all goes dark at some point, but continues on infinitely. This in itself opens up very bizarre possibilities of chance and infinite time, such as the formation of a Boltzmann brain, where random fluctuations, if given enough time, will cause some kind of a consciousness to randomly appear in the dead universe out of nowhere. But it could alternatively be that the universe will someday meet an end. This debate is not settled within cosmology, and there have been many potential ends of the universe advanced, but two possibilities stand out. The first is if the proton is capable of decaying. This is an unknown, but if they indeed do decay, the universe will effectively end when they do, given that all matter in the universe will simply dissolve. Another possibility is that the universe itself is somewhat unstable in that it doesn't exist at its true vacuum state. If something were to happen within the universe that pushed some part of it to the true vacuum, the results would be disastrous. Expanding at the speed of light, the entire universe would be ripped apart as it moved to the true vacuum. This could dramatically alter how the universe works, such as how gravity functions or how matter is structured. The universe as we knew it, at least, would no longer exist, and we very likely wouldn't survive it. Thankfully, the time frames for this to happen are very likely far longer than our species can exist within the universe. Number 6. What set off the Big Bang? Regarding the Big Bang generally, the earlier you go in that process, the less it is understood by current science. Known as the Planck epoch, when applied to the very first moments of the Big Bang, the theories that physicists rely on to describe the universe, particularly Einstein's general relativity, no longer predict what exactly happened. What can be done is somewhat informed speculation based on evidence of the Big Bang, such as the cosmic microwave background radiation, and there exist several scenarios that might someday prove to explain what exactly happened. One possibility comes from string theory and its variants, where the universe is suspended on a kind of membrane. When this membrane collided with another membrane, that impact set off the Big Bang. Others include that the whole thing was set off as a result of quantum fluctuations, or that the universe is one of many in a kind of multiverse, where universes bud like flowers on a tree off of other universes. Also, suggestions have been made that the universe is the other side of a black hole, known as a white hole, where matter leaves the black hole. Whatever the case may be, because we have no way of seeing what happened during the Planck epoch, it's entirely possible we may never fully understand what exactly happened. Number 5. Spooky action at a distance.
We often view the universe as a place of immense distances. Any two objects can be separated by almost unfathomable distances, so distant that they can't ever even observe each other. But that absolute concept of separation is not necessarily set in stone in the quantum mechanical world. In fact, separated particles can be connected to each other through a phenomenon of quantum mechanics over vast distances and influence each other instantaneously, so long as they had some physical interaction in the past that entangled them. Einstein called it spooky action at a distance and absolutely hated the idea, but the phenomenon of quantum entanglement is real and has been experimentally proven. Put simply, if one particle changes behavior, such as its spin, the other reacts instantaneously no matter how far away it is. Unfortunately, this behavior cannot be predicted, meaning that it can't be used to convey information. The universe does not allow information to propagate faster than light. Exactly how this occurs depends on what interpretation one holds of quantum mechanics, though ultimately we may never know exactly how particles do this, just simply that they do. Number 4. 11 dimensions of space and time. Regarding our last entry, one of the ways quantum entanglement might work is that particles might not be connected spatially in the dimensions that we perceive, but might be closely connected in another dimension that we can't perceive. While it's still very much up in the air whether other dimensions exist or how many there could be, there are hypothetical possibilities, particularly within the realm of string theory. One interpretation involves 11 dimensions, 10 of space, 1 of time. The reason we do not see these other dimensions of space is because they are curled up and thus imperceptible to us. But at the very first moments of the Big Bang, they may not have been and may have played a role. Whether this is the case or whether other dimensions even exist at all could remain open forever. Number 3. Time travel is possible, at least in one direction. Is time travel possible? The arguments against traveling to the past are numerous, especially because it would violate causality. It's the old what happens if you go back in time and kill your own grandfather scenario. Would you cease to exist? But that's only part of the story of time travel, and it may not be as set in stone as you might think. Now, travel to the future is easy. It's literally built into the universe, and you're doing it right now as the clocks tick. Because of relativity, however, very high accelerations can affect time in a process called time dilation that allows you, in your frame of reference, to travel into the future simply by accelerating. This is exemplified by the twin paradox, where one twin stays on Earth and another twin travels through space at relativistic speeds, and when he gets back, he's no longer the same age as his twin. Even on smaller scales, satellites in orbit have to be corrected for minute amounts of time dilation. So, in short, if you go extremely fast in space, you will travel forward in time at a different rate than someone sitting here on Earth. Trouble is, if you go 500 years into the future, you have no way of ever getting back to your own time. Or do you? The answer is maybe, but it wouldn't be easy, and in all practicality it is likely impossible. But this may not mean that backwards time travel is strictly impossible in the universe. Hypotheses exist that under very special conditions, such as if you had a rotating cylinder of infinite length, or under certain conditions involving traversing a black hole or a wormhole, not through space but through time, might allow you to at least in principle travel backwards. But that we do not appear to see time travelers from the future visiting us suggests that we will never figure out backwards time travel, or it's illegal, or we simply go extinct before we figure it out. Number 2. The universe will someday be mostly invisible. In this option, we actually do understand what's happening, or at least parts of it, but in the very far future, anyone that might exist very well may not understand the vast majority of the universe in the way that we do. This is because as the universe ages and continues its expansion, everything but your local group of galaxies will be so distant that light cannot travel fast enough to make up for the expansion of the universe in between. Essentially, a civilization existing in the old age of the universe will have no idea that countless other galaxies exist in the universe because they will all be invisible. They may not even be able to determine that a Big Bang ever happened or know anything about the universe as it is today. They may be able to study their local group of galaxies and glean some clues about the nature of the universe, but even worse, an isolated rogue star system in the intergalactic medium might not even have that option available to them. They would essentially be marooned on their world until the effective end of the universe itself, never knowing very much about it at all. Number 1. The many worlds interpretation. It's possible to take a completely different approach to the concept of parallel universes.
different from the concept of a multiverse. In the 1950s, Hugh Everett hypothesized that other universes could exist, hovering, for lack of a better term, alongside our own, constantly splitting off from each other, and that events in those universes may all have different outcomes. This leads to some strange ideas, such as that in a parallel universe, the dinosaurs did not undergo a mass extinction event, and that humans never evolved as a result, leading to a modern Earth still dominated by dinosaurs, perhaps even intelligent ones. Other possibilities are well explored in science fiction, from everything from what might have happened if the Allies had been defeated in World War II to evil alternate universe Spock with a beard. This may seem far-fetched, and it is, but not the underlying reasons why Everett hypothesized the possibility. Within quantum mechanics is a question, one related to the double-slit experiment. Why does quantum matter behave so strangely? Why do particles take different forms? Niels Bohr hypothesized that these particles don't actually exist in any one state at all, but all possible states, and that observing the particle forces it to pick a state, but that's only one take on it. In Everett's interpretation, when a particle chooses a state, it actually causes a split in the universe itself, creating an entirely new universe branching off from another, explaining why particles can be measured in different states because they exist in all possible states spread across parallel universes. In the world of the big above the quantum level, this means that there could be universes in which you are dead, or a very different person. Whether these parallel universes exist or not is an open question, and probably will never be answered, as it doesn't seem possible we could ever detect or measure these other timelines. But this concept of collapsing wave functions can be taken to an even more profound level. Some have asked the question, does the entire universe have a wave function? Would it even exist if it weren't being observed? It's hard to believe that would be the case, but it is a question, by its very nature, we probably cannot ever answer for sure.
Event Horizon and my channel are now available as a podcast on Apple Podcasts, Spotify, and YouTube memberships. Early ad-free episodes, bonus episodes, and sleep-focused content.
One of the stranger objects in our solar system is also one that gets very little attention in comparison to planets like Mars. In reality, however, Venus stands as a planet completely unique in the solar system and harbors some of the solar system's oddest natural features. So here are 10 strange aspects of planet Venus. Number 10. It snows metal. When radar images of the surface of Venus were taken, it was noticed that certain high elevation areas on Venus were highly reflective. Initially, the reason for this was unknown, and explanations such as loose soil and weathering differences were advanced, but none fit very well. It was later found out that Venus may contain minerals that evaporate in the intense heat of the lowlands, and then precipitate out at cooler, higher altitudes in the form of lead and bismuth sulfides. This happens at altitudes higher than 2,600 meters in a process that can be compared to Earth snow, but only superficially. The two, in reality, are radically different. Number 9. It's a planet gone horribly, horribly wrong. It has been said that Venus is, in many ways, Earth's twin. Its evil twin. Venus was once very Earth-like, and may have even had oceans of liquid water for a time billions of years ago. But then something happened, and Venus transformed itself into the vision of hell that it is today. But what was that something? It's thought that Venus is an example of a runaway greenhouse effect. As the young sun increased in luminosity, which it's still doing today and will eventually bake Earth, it's thought that the Venusian oceans began to evaporate. Water vapor is an insulating greenhouse gas, and would have warmed that planet's atmosphere further. Eventually, the oceans boiled away completely. But today, Venus has comparatively little water vapor, so where did it go? In short, it's thought to have escaped into space. One clue for this is another odd aspect of Venus. It has a very high ratio of deuterium to hydrogen in its atmosphere. It's 150 times greater than that of Earth. It could be that Venus's water vapor made it high enough into the atmosphere to be broken down by solar radiation. The resulting oxygen would recombine, providing some of Venus's current carbon dioxide atmosphere, which is also a greenhouse gas. But the hydrogen would escape, being too light for Venus to hold on to. But the isotope deuterium is heavier, and would generally be more easily retained, resulting in the higher concentrations in the atmosphere over time. It's essentially the leftovers of the ocean. The end result is the Venus we have today, with searing hot surface temperatures, extreme atmospheric pressure, and a runaway greenhouse effect on a world that at one time seems to have been Earth-like. But that's not the end of the story for Venus. In the far future, it's an attractive candidate for terraforming, and may someday end up as a true twin of Earth, and like Earth, inhabited by humans. Number 8. Venus has astonishingly high wind speeds. Venus's upper atmosphere in some ways behaves like Earth. For example, wind speeds in the upper atmosphere are comparable to Earth's jet stream, which can exceed speeds of 100 miles per hour. Generally, wind speeds deeper within Earth's atmosphere are slower, except under certain weather conditions, such as a tornado. Venus, however, has a very different lower atmosphere and much higher wind speeds. Lower in Venus's atmosphere, wind speeds can reach past 700 kilometers per hour, or 400 miles per hour. This is far faster than any wind speed ever recorded on Earth. But as you move down even deeper into the atmosphere near the surface, the extremely high atmospheric pressure drops wind speeds to almost nothing, and behaves a bit more like a liquid flowing than a gas moving. But at pressures that great, even slow winds can move rocks. And there's also a mystery involved with Venus's winds. Based on cloud-top observations, Venus's wind speeds appear to be increasing over time, suggesting a cycle of some sort. It's unclear what's causing that. Number 7. The entire planet has recently been resurfaced. One noteworthy thing about Venus's surface is that it has very little cratering when compared to other objects in the solar system. This suggests that its surface is young, having recently been resurfaced an estimated 300 to 500 million years ago. Earth resurfaces itself as well, but in our case, in addition to weathering, we also have plate tectonics that return material from the crust to the mantle and vice versa. Venus does not appear to have active plate tectonics. This opens up a very apocalyptic possibility, that as radioactive materials in Venus's core decay, they produce heat, but that heat becomes trapped, causing the mantle of the planet to heat up until eventually mantle material is so hot it forces itself up through the crust, causing a planet-wide lava flow. In short, Venus may periodically crack open and resurface itself. Number 6. From the perspective of Earth, Venus does strange things. Being among the brightest objects in the sky, Venus has been watched in the night sky by humans for many thousands of years, probably the entirety of our existence on this planet, in fact. But also, due to that brightness, Venus can often be observed in the daytime through a telescope if you know where to look. But historically, occasionally, somehow it seems to have been fully visible to the naked eye in daylight. In 1716, Edmund Halley calculated its brightness when residents of the city of London became alarmed over a daylight apparition of Venus. Other times this seems to have happened was during the 1865 second inauguration of Abraham Lincoln. More, Napoleon Bonaparte likewise witnessed a daylight apparition of Venus while in Luxembourg. In the past, these daylight apparitions were looked at superstitiously, but in reality, Venus can become naked eye visible from Earth if the planet is positioned well and seeing conditions in the sky are good. But that's not the only oddity involved with Venus as we see it from Earth. Telescope visual observations of Venus hold a mystery known as the ashen light. Over the centuries, there have been reports of a glow on the unilluminated side of Venus, which, like the moon, goes through phases. No one really knows what causes it, or if it really exists. It could be an illusion, where when observing a small but very bright crescent, it is perceived by the brain to be a complete circle. Others have suggested that it may be due to lightning in the Venusian atmosphere, or some kind of auroral activity, and even upper atmospheric chemistry. Yet, we've sent spacecraft to Venus and none of them have detected this light. On the other hand, reports of it are really persistent, stretching back to 1643 with many credible astronomers witnessing it, even to the present day. Number 5. Venus may or may not have a solid core. One striking feature of Venus is that it has little or no magnetic field of its own. Rather, it effectively borrows the magnetic field it does have from the solar wind, leading to a comet-like magnetic tail quite unlike Earth, which internally produces its magnetic field through convection of liquid in the core. An Earth-like convection deep inside Venus does not appear to be occurring, leading to the possibility that Venus has a solid core. But if it's so similar to Earth in composition and size, why wouldn't it be liquid? Another possibility is that it's simply too hot for convection to occur, bolstering the idea that Venus traps heat. and only occasionally releases it when it cracks open and resurfaces itself, in which case it has a molten core, but one very different from Earth. Number 4. Venus rotates very slowly and backwards. One of the strangest aspects of Venus, and one of the hardest to explain, is the fact that the planet rotates backwards in respect to the rest of the planets of the solar system. It also rotates very slowly. Its day is 243 Earth days long, which is actually longer than its year. While it might seem intuitive to suspect some past cataclysm is the reason for this, such as some kind of impact, that doesn't appear to be the case. It may be that Venus simply formed a little bit differently within the solar nebula than the other planets, and that some mix of tidal effects from the Sun's gravitation on Venus's thick atmosphere and chaotic spin changes through planetary perturbations affected how it rotates today. More, it's unclear what the effects on the planet are with that thick atmosphere and very high winds, but Venus may not be without its cataclysms. If researchers at the California Institute of Technology are correct, Venus may once have had a moon created in a similar way to how Earth's moon is thought to have been created. A huge object crashed into Proto-Venus and knocked the material off that would coalesce into a moon. But here's the kicker. About 10 billion years later, another impact reversed Venus's spin direction. This would have caused the moon to spiral inward and impact Venus. Alternatively, the strong solar tidal effects might have destabilized the moon, explaining why Venus is oddly moonless for a planet in our solar system. Number 3. Venus may have lightning, but it shouldn't. When it was first suggested decades ago that Venus might have lightning, it sparked a controversy within the scientific community in that it really shouldn't have lightning. Venus lacks the type of clouds that generally produce lightning, and also lacks the vertical atmospheric convection that is a major factor in the generation of Earth's lightning. Yet, persistent measurements with exploratory spacecraft have seemingly unambiguously detected lightning on Venus, and seems to be about as common there as it is here on Earth. What mechanism creates that lightning remains uncertain. Number 2. If the wrong things happen, Venus may someday collide with Earth. The further one tries to project how the future of the solar system will play out, the more uncertain it is. Modeling this often produces varying results, but what is certain is that it will change, and the current arrangement of the planets will undergo changes, and some scenarios can be a bit disturbing if unlikely. One possibility is that the planet Mercury could see its orbit become even more elongated than it already is, causing gravitational interactions with the rest of the solar system that could eject it entirely from the solar system, or put it on a collision course with Venus. Still, other possibilities include a small chance of Earth getting ejected from the solar system, or even a collision where Mars passes very close to Earth, disturbing Venus and Earth, putting them on a collision course. But never fear, these are among the least likely scenarios for the future solar system. What is certain, however, is that nothing will stop the evolution and aging of the Sun, and Earth is most definitely in long-term danger there. But planetary migration is something that can be managed over very long periods of time. Yes, it's possible to move planets, links to a collaboration I did with Fraser Cain on that very subject in the description below. And in the far future, if we're still around, we may be able to avert these collisions by shepherding the planets using the gravitational influence of asteroids in deliberately altered orbits over very long periods of time. Number 1. Venus may have life. At first glance, with all of the heat and pressure, Venus would not seem to be a possible abode for life, at least as we know it. But in fact, it is a candidate, and may be showing signs that some kind of biological activity is occurring there. The key to this is the upper atmosphere of Venus, where temperatures and pressures drop to a situation similar to the surface of the Earth. In fact, this level of Venus's atmosphere is among the most Earth-like places in the solar system. Given that Venus may once have had liquid water, it's possible that microbial life arose there, and as the planet slowly transformed into what it is today, that life adapted to the changing conditions and may still be present in the upper atmosphere. And we may be seeing clues of this. The first of these is the chemical carbonyl sulfide. This chemical is difficult to produce inorganically, though it can be produced through volcanism. Another odd one are what are known as S8 molecules, which are impervious to the effects of sulfuric acid. If the microbes had incorporated these molecules into their makeup, they too might be impervious to the corrosive effects of the sulfuric acid in Venus's atmosphere, S8 molecules are known to exist in Venus's atmosphere. More, the Venera missions detected unexplained elongated particulate matter in Venus's lower cloud layer that were about the size of a bacterium. But perhaps the most tantalizing hint are dark streaks that appear in Venus's cloud layers that appear to be absorbing UV light, and it's not clear why. But if those streaks are related to life, then UV could be its energy source. Hopefully we won't have to wait long for an answer. Roscosmos is planning a mission, Venera D, and if sent, may carry equipment to try to detect that life directly. This is another collaboration with astrophysicist Paul M. Sutter of Ohio State University. This time we're looking at the 10 best and 10 worst places to be in the universe if you're a human. For part 2, check out Paul's channel, link in the end screen and in the description below. Now, without further ado, here are the 10 best places in the universe if you're a human. Number 10. The upper atmosphere of Venus. Venus is a very strange planet. On its face, it looks like the absolutely most awful place you could possibly find in a solar system. It's a hellish environment of sulfuric acid, crushing pressure, and extreme heat from a runaway greenhouse effect. But at the same time, it boasts a layer in its upper atmosphere that is one of the most clement and Earth-like environments in the solar system, so much so that if you lived in a balloon colony suspended in the atmosphere at this level, you could accidentally tear your spacesuit and not die, and in fact, take your time getting back to your colony. This is because within this zone the atmospheric pressure is the same as Earth, meaning you don't get gases leaking in or out as badly from the tear as you would, say, on Mars, where the low atmospheric pressure would suck the air out of your suit very rapidly. This is one of the few places in the solar system other than Earth where this can happen. As a result, Venus is an interesting planet to humans. Though currently often overlooked, it has enough resources to be terraformable over a long period of time, and it has that clement area where humans can hypothetically live while that terraforming occurs, though that colony would likely be highly dependent on Earth for centuries. And there is a potential astrobiological technosignature in this one, as we gain the ability to study exoplanet atmospheres and say we see what should be a Venus-like world given its placement in its system close into its star, but instead appears atmospherically to be an unlikely analog of Earth as far as oxygen levels and chemical composition goes. It would need to be considered that someone may have made it that way. Number 9. TRAPPIST-1d.
The search for and the discovery of exoplanets has absolutely exploded in recent years. We know of hundreds upon hundreds already, and we suspect there are many more. As a result of this, we can now say with confidence that planets aren't rare in the Milky Way. But what of planets like Earth? We simply don't have a good understanding of how common our planet is. It could be an exceedingly rare type subject to a very specific circumstance, which increasingly seems to be the case, but there could be others in the galaxy. But so far, we have not seen a twin of this world. But we do have one that may come close, at least we think it is right now. It's a planet in orbit around the red dwarf TRAPPIST-1, and it currently holds the highest score on the Earth Similarity Index out of any other exoplanet, 0.91 out of 1. Study of this planet is ongoing, and it could well go down. But as it stands, new data shows that as much as 5% of the makeup of this planet seems to be water, very possibly in liquid form. In other words, it may have oceans. Also, studies with Hubble showed that the planet lacks a thick hydrogen atmosphere, opening up the possibility of a more Earth-like atmosphere. But we know little else. It could be a greenhouse effect atmosphere like Venus or a carbon dioxide one like Mars. But if it turns out similar to Earth and we start seeing odd oxygen and methane levels as ongoing study continues, then life would be on the table as the origin for that.
Number 8. Colonized ice shell moons. When we think of colonizing a planet, we tend to think in terms of habitat domes and eventual terraforming. In other words, recreate on another world the conditions of Earth where we evolved. Key to this is the one thing that we're going to need lots of anywhere we choose to colonize, an ample supply of liquid water. But we are land creatures fundamentally, yet we venture into the oceans with submarines and ships. It also pays to remember that Earth also has water environments that teem with life that, hypothetically, could also be colonized. Realistically, underwater colonies in Earth's oceans would be limited to shallow waters to avoid having to deal with the extreme pressures of the deep, but they are in principle possible with the right technology. Trouble is, there's no reason to do this on Earth. But in thinking about colonizing a body that doesn't have a land environment quite like Earth, rather an ice shell, but does have liquid water oceans beneath, it might be viable to locate such a colony in that ocean rather than at the surface. The obvious candidates for this are the ice shell moons like Europa or Enceladus. While surface colonies likely would end up being more practical on these moons should we ever choose to do it, underwater components could also be useful, especially in regards to harnessing any geothermal energy present at these places. The high pressure in these oceans opens up questions here, but ultimately an ocean environment is at least more familiar to humans than the surface of a frozen Jovian moon. Number 7. Ignorance is bliss.
We live in a time where it is at least possible to largely understand the universe, though we are still very much within the learning curve. But there is a part of our universe so distant that light does not travel fast enough to overcome the rate of expansion of the universe in between. Barring faster than light travel, we will never see this part of the universe, and we don't know how large it is. And it gets worse. As the universe expands, eventually everything becomes so distant from everything else that eventually isolation becomes the rule. As a result, future civilizations may have no way of ever knowing the Big Bang ever occurred, or that there's an entire universe out there. As such, why pay attention to the blackness of space outside of your own galaxy? Future scientists may say that nothing could come of it, and they may well conclude that their galaxy is all that there is, and it might as well be. What exists outside of what you can know or what affects you is meaningless. Just as it's meaningless to ask what happened before the Big Bang and the onset of time, if that concept even makes sense. This limited scientific toolkit could leave a human-like future civilization in a kind of blissful ignorance, never able to know that their universe could someday come to an end.
Number 6. Calm super-Earths. Earth is an amazing world, but it's by no means perfect. At times in its history, it's nearly frozen over, has caused mass extinctions from periods of widespread volcanic activity, frequently features extreme weather, and all manner of other natural disasters. Earth can be a harsh planet, but what of planets that might be a bit calmer? It's possible to envision a world perhaps a bit larger than Earth, in circumstances that may make it possible for it to experience less extreme weather or a lack of ice ages, and perhaps placement in a star system that sees less asteroid impacts and so on. As such, it may be possible that there are worlds out there that are better for humans than Earth is. Oddly though, this may only be true for us humans. Any species native to such a world faces a possible challenge. It may never evolve intelligence. With better, more clement conditions comes less of a need for intelligence. It has been suggested that the general lack of true intelligence in sea life on Earth, most intelligence in the ocean is limited to animals that evolved to go back into the ocean after a period on land, might indicate that oceanic life has it too easy. This may be true for land life on a clement super-Earth. And worse, water itself can become an enemy. On full-on water worlds, where no land exists but very deep oceans do, the conditions of Earth-like life may never arise. Volcanism may never occur on these worlds, for example, and certain gases needed for heating might not get released into the atmosphere, perhaps creating ice shell conditions, where the liquid water is locked up under the ice. Life might exist, but it might also not be able to progress past a certain point. Number 5. Goldilocks zones.
As the Earth illustrates, where you are located in relation to your star is crucial to the evolution and existence of life as we know it. Known as zones of habitability, or the Goldilocks zone for being just right, they provide a basic framework for what planets Earth-like life and humans can comfortably live on. The first of these zones are the circumstellar habitable zones. This essentially is where Earth lives in our solar system, just the right distance from the sun for liquid water. This zone depends on what type of star a planet orbits, and this zone can be close into the star if it's cool, or far from the star if it's hot. But there is also a galactic habitable zone. This one is more forgiving in that a large part of the stars in our galaxy is within it. But certain areas such as the center of the galaxy or inside a dense star cluster probably would not host planets where humans could easily live, if at all. The reason for this is that you're simply too close to other stars and subject to their radiation and nearby supernovas. At the furthest reaches of the galaxy, you don't have that problem. But that far out presents other issues that may make it uncomfortable for humans, such as a scarcity of raw materials. Of course, habitable zones are subject to exceptions, such as the ice shell moons like Europa, and with technology, humans could live far outside these zones, but as a matter of the best places in the universe for humans, the habitable zones provide the best starting conditions.
Number 4. Virtual realities. While it could be said that some basic clement environment is needed for human life, that equation may change in the future when humans are able to alter our own biology or abandon it entirely. There, the rules change. For machine life that was once human, a broad variety of environments open up, including that of deep space. In fact, if the speed of the calculations being performed by a formerly human computer are a concern, the colder the environment, the better. But would humans as technological beings even care about what their actual physical environment is like? Would Earth still matter? We don't know yet, but it may be that the best environment for a technological human is a total virtual reality that's superior to anything that exists in the real universe. Why pay attention to this universe when a digital utopia can be created that better suits the human condition? So here the concerns for where we would be most comfortable depend more on efficient calculation and massive energy production to keep it all going, rather than the concerns of suitable atmospheres and warmth. Number 3. Improved Earth.
One of the things that advancing technology allows us is greater control of the circumstances Earth finds itself in within the solar system. Ultimately, we will be able to essentially improve Earth by gaining greater control over certain risks, such as that posed by asteroid impacts. In the past, Earth was not nearly as clement as it is today, and in fact, early in its history could not support life at all, and was subject to constant bombardment. Asteroid impacts can still happen, and with technology we can deflect or even destroy problematic asteroids. But in the future, Earth will eventually become uninhabitable again, but not necessarily so if we develop technologies to literally move Earth, or move somewhere else as the sun brightens and eventually becomes a red giant. This is not as far-fetched as it might sound. By orchestrating asteroids to pass by Earth and provide a small but non-zero gravitational tug on the planet, over very long periods of time, on order of hundreds of thousands or even millions of years, the planet could be migrated to wherever we want. So to some degree, we could, hypothetically, improve our world by giving it longer life in a changing solar system, or protect it by mitigating planetary risks like asteroids, or even building orbital sunshades to mitigate its growing luminosity.
Number 2. Better than Earth. Earth is a wonderful world located in an amazing solar system that all happen to allow conditions that have resulted in the rise of life, intelligence, and a civilization. In a way, human civilization, for all its faults, is still an encouraging indication that other civilizations could exist in the universe. And often we imagine them as being more advanced or more enlightened than we are. That may or may not be true, but Earth is not necessarily perfect. While it has the conditions conducive to the development of intelligent life, it can also be subject to conditions that might cause intelligent life to go extinct, such as the aging and eventual death of the sun, or asteroid and comet impacts. But in the end, if we stay in this solar system, the conditions of it will, long term, likely force us to look elsewhere for habitable worlds. And while nothing in this universe is going to be perfect, including the universe itself, which will eventually become inhospitable to life in its own right, there are some cases where we might find worlds better than Earth that could remain habitable for far longer of a period than this planet could. One factor would be stellar types. The Sun is a Type G yellow dwarf that will eventually expand into a red giant and finally settle down to be a white dwarf. While there are hypothetical ways to keep Earth, or at least some body in the solar system, habitable during all three phases, it might be better to just inhabit another star system entirely that will remain stable far longer than this one will. This includes the Type K orange dwarfs and Type M red dwarfs, both of which live far longer than our star, and they are happily far more numerous than any other kinds of stars in the Milky Way. So, as far as long-term human survival is concerned, there may be worlds located in perfect sweet spots within the habitability zones of mature red dwarfs and orange dwarfs that might yield planets better than Earth if we as humans tweak them with terraforming. Number 1. Artificial worlds and habitats. The case can be made that only humans know what's perfect for us. Our own planet can, at times, become unpleasant or even uninhabitable, but being human, we can also envision technologies that would allow us to alter a planet's climate, or even create a completely artificial environment that maintains ideal conditions for human life. We already do this to some degree with air conditioning and heating, but on a planetary or even larger scale, we could do this with far larger amounts of space than we have here on Earth. The first such option would be a terraformed world, a natural planet that we have used terraforming techniques to alter to make for a better environment. But that's not the only option. It's also hypothetically possible to build megastructures and even artificial planets that can be inhabited by humans and maintain a perfect environment for us. These include Dyson spheres around other stars, or partial variants of that idea, such as Larry Niven's ring world, but also enclosed rotating habitats, such as O'Neill cylinders, that make use of centrifugal force to produce the effect of artificial gravity. Such an environment could be perfect for long-term human habitation.
So here are 10 ways we may have already detected alien life in the universe. Since the advent of space science, the human race have asked ourselves, are we alone? In the past, answering this question seemed more straightforward than it is today, with Percival Lowell's canals on Mars and pulsars being the signals from little green men. But none of that panned out, and the fact is, we still don't know the answer to the biggest question in the universe. But we do know that life itself, at least microbial, seems fairly straightforward, resilient, and easily arisen, and may have done so on multiple bodies in our solar system alone. It seems likely that we are on the cusp of answering the question, at least as far as simple life is concerned. But what of other civilizations? This too seems to be increasingly moving into the territory of getting answered. If NASA researchers are to be believed, it could happen at any time and probably will within the next 20 years. But in this search, we must be careful and cautious to prove that whatever we find does indeed indicate the existence of extraterrestrial life. That has not been easy so far. It's worth noting that in the search for extraterrestrial life, there have been many false starts, so it pays to take this entire list with a grain of salt. Two examples of this are HD 164595, a sun-like star with a known planet that appeared to be the origin of a radio signal, and it became a major SETI target at the time. But the signal didn't repeat, which is SETI's chief criteria, and it turns out that the signal was within a military communications band. In other words, the origin was very likely a human-launched spy satellite whispering secrets from orbit. The other example would be the near-Earth asteroid 1991 VG. It's a highly unusual asteroid that has a really odd orbit that's a bit hard to explain. It's very similar to Earth's orbit, and that means Earth should have long ago flung it out into space or smacked into it. It also has really strange, almost artificial-looking reflectivity that makes it change brightness as it rotates, to the point that one theory for its origin was that it was a spent rocket stage that someone had forgotten about. But one other possibility that was floated at the time was that it was an object of alien origin known as a Bracewell or von Neumann probe, more on those later. But over the years, further research has revealed that it's just a strange rock, and the alien origin possibility for it is now dead. This list starts with the least likely candidates and ends with the most likely to have been something of alien origin. I included all life in the criteria because even a single microbe answers the question. That is not to say that any of the cases will yield the answer to the "are we alone" question, since some of the options are unlikely to repeat, and thus probably won't be available for further study and will forever remain mysteries. There are also some notable omissions for possible life, for example Europa, where we currently have no indication that there could be life there, but the conditions are such that it would be unsurprising if such evidence were found in the near future. Those omissions are for a future dedicated list. Number 10. Tesla's signals. This case suffers from being obscured by the mists of time and also a mistaken viewpoint of the period that Mars was almost certainly inhabited by an alien civilization. It clearly is not. The only alien civilization with a presence there is us. There's also a ton of misinformation out there on the internet regarding the originator of this possibility, and many urban legends have been spawned from material surrounding Nikola Tesla. But the underlying claim does technically remain unexplained, though as I understand it, and this comes from very old information I heard long ago, it would be extremely difficult to verify today because the frequencies at which it was supposedly visible are so saturated by Earth interference that you'd have to put a receiver on the far side of the moon to block everything and check them out. Nikola Tesla on several occasions claimed that he received unambiguous alien radio signals from space, but he never gave much in the way of details that we could investigate today. He typically associated them with Mars, which at the time was subject to claims from several mistaken observers to have canals on it. It does not, and as far as radio goes, Mars is about as uninteresting of an object as you can get. Now, I don't doubt that Tesla did in fact receive strange radio signals during his experiments. But those were the very earliest days of radio astronomy, done at a time when we had no idea what could emit radio waves. It turned out many things do, including objects in our own solar system. You can literally grab an old shortwave radio and make a loop antenna, and listen to Jupiter make repeating, ocean-like whooshing sounds that, if you didn't know were natural, could be mistaken for something else. As a result, I think this is a case of smoke without a fire, but since it technically remains unexplained, I put it on the list. Who knows what Mr. Tesla heard? Number 9. Long-delayed echoes and von Neumann probes. This gets into unexplained radio phenomena that are almost certainly of natural origin, but since we haven't pinned down exactly what causes them, there remains a rather spooky possible alien origin, though it is so far beyond unlikely and so highly speculative that I'm barely comfortable including it. But since it's technically possible, on the list it goes. In radio, there is something called a long delayed echo, or LDE. These occur when a broadcaster sends out a signal and then receives it back after a long period of time has elapsed, often tens of seconds. Now, there are lots of possible scientific explanations for these that include signals getting trapped into a loop going around the Earth when the conditions are just right in the upper atmosphere, and signals can bounce off objects in space in return. While we don't yet know for sure, the explanation is most likely natural. But the universe is extremely old, easily old enough for an advanced species in the galaxy to have developed. One possible way for such a species to explore the galaxy is to use self-replicating von Neumann probes. These are probes that can make copies of themselves like viruses and spread out into the galaxy to explore it. The most famous example of this in science fiction would be Arthur C. Clarke's monoliths from 2001: A Space Odyssey. With probes of this type, you could theoretically put a probe around every star in the galaxy. That would not take long. It could be done in as little as 500,000 years. But if your civilization is millions of years old, then that's not really a big deal. And the expenditure of resources to do it would be very low. You would only need to build a few initial probes and send them out to self-replicate. It's actually a scary, doable way to explore a galaxy for a sufficiently advanced species. So much so that we're not that far from being able to start this process ourselves. In fact, this method is seemingly so easy that one of the major arguments against it is that if von Neumann probes exist, they should literally be everywhere and should have consumed most of the galaxy by now. So much so that any civilization that comes across one might see it as an existential threat and destroy it. There are arguments for, against, and neutral as to the existence of von Neumann probes and their implications on the Fermi paradox, but it does open up the possibility of such a probe being stationed in our solar system, awaiting the proper time to initiate contact and cultural exchange with us. One way such a probe might announce its existence is to repeat radio signals back to the civilization emitting them, sort of like the aliens from Carl Sagan's Contact, sending back images of Hitler opening the 1936 Olympics as a sort of initial way to say hello. Could that be the origin of at least some of the LDEs? It's highly unlikely, but possible. So on the list it goes. Number 8. Gamma ray bursts and Alcubierre drives. This possibility makes use of a very contentious, hotly debated, highly theoretical advanced technology called an Alcubierre warp drive. In a nutshell, the idea is that while matter sitting in normal space cannot travel faster than the speed of light, space itself is not subject to that rule. So if you can split off and accelerate a piece of space, you can theoretically make it go as fast as you want. If you have a spacecraft generating a field of sorts to split that piece of space off and send it traveling, it would carry the spacecraft sitting within it along, and voila! Faster than light travel becomes possible and still remains consistent with relativity because the spacecraft isn't actually moving. The space it's sitting in is. I will go on record and say that I do not think Alcubierre drives are possible. The subject is fraught with all manner of arguments against it being possible in practice, not the least of which is truly titanic energy consumption needed to make it work. But it does have its advocates, and the basic core concepts involved are fully scientific, so I include it on the list. One effect of an Alcubierre drive is thought to be the generation of huge amounts of gamma rays. These should be detectable at long distances, and we do, in fact, see all manner of strange gamma ray bursts in the universe that are not well understood. One possibility, be it a diminishingly tiny one, is that these bursts are being produced when aliens fire up their warp drives. Number 7. The Borah-Trottier signals. In 2012, Ermanno Borah released a paper that suggested that you could detect within the spectra of stars the presence of pulsed laser emissions consistent with the activity of alien races. Along with E. Trottier, Borah then searched through the Sloan Sky Survey for the presence of these signatures. At the end of last year, Borah and Trottier released a paper that reported that they had indeed identified these kinds of signals in the Sky Survey. But it wasn't just one or two stars emitting them, it was 234 different stars in the Milky Way, and the stars that were emitting them were overwhelmingly sun-like, meaning that they had sufficient age and stability for them to have developed advanced alien civilizations. But stars are strange and emit all sorts of signals, so natural explanations are always favored. But to date, no follow-up papers have been published regarding this story, so it's very much in flux still. But at the time, scientists were careful to caution that on a scale of 1 in 10, with 10 being the least likely, these signals were a 10. Only time and more study will tell. Number 6. Fast radio bursts. Fast radio bursts are a fairly recently discovered phenomenon. While it's overwhelmingly likely that these are of natural origin, one theory suggests that they may not be and are consistent with an alien civilization using a beam to push solar sails, and the FRBs are the result of leakage from those beams. What's noteworthy here is that FRBs do not seem to be consistent with something large, such as a star or galactic core. This is not yet settled, but it seems that they would be more consistent with something originating from a much smaller object, such as a planet. If so, that would help bolster the solar sail theory. But where it gets strange is that the solar sail theory makes note of an odd coincidence involving FRBs. If you take the theory from the position of energy and extrapolate what you would need to power the FRB beam, it comes out that you would need a planet about twice the size of Earth to have enough room to collect solar energy to create the beam. On the other hand, if you take the theory from the position of engineering and likewise extrapolate what you would need to actually build the beam emitter, it ends up that the characteristics of FRBs would be consistent with a water-cooled structure that also happens to be the size of a planet about twice the size of Earth. I stress that FRBs are probably natural in origin, but it's also hard not to scratch your head when coincidences like that start popping up. Number 5. KIC 8462852. With this case, we enter a new level of possibility because it's the first case where the natural explanations thus far advanced have all fallen short, and the alien origin theory still has not been discounted. KIC 8462852, or Boyajian star, is an enigma wrapped within an enigma. The Kepler spacecraft observed the star long-term in 2011 and found that within the light curve of that star there were strange dips present as something passed by and blocked the star's light. This in itself would not be unusual. Lots of young stars have disks of debris where planets are forming around them that produce light curves just like the one at Boyajian star. But the star's motion strongly suggests that this star is not young and should no longer have such a debris disk. That led to the possibility that two planets had crashed into each other in the system, creating a new disk. Sounds fair enough, but there are two problems here. The odds that we would just happen to be looking when a very short-term event like that happened are, well, astronomical. The second problem, and this discounted that theory, is that such disks absorb light from their star and radiate it back out in the infrared. No infrared radiation was detected at the star consistent with this. Whatever it is, if it's any kind of material, it has to be cold. But comets are very cold objects, so the next theory to come up was that a red dwarf, which is there, is passing by Boyajian star and disrupted its Oort clouds, sending a hail of cold comets towards the star. Again, this would seem to be a perfectly reasonable explanation. You have the red dwarf as the culprit, and we know from our own sun that Oort clouds exist, and comets do get disturbed from them and head into the inner parts of solar systems. But then this theory fell short when sky surveys taken over the last century showed that the star doesn't just dim in short-term dips. It has been dimming overall for over a century. This would mean that you'd need a lot of comets in increasing numbers to account for this. The number needed is hard to swallow, on the order of 648,000 comets all orchestrated to pass in front of the star. That renders this explanation possible but implausible, so other natural explanations are better candidates. The problem is, every other theory involving a natural origin has some kind of Achilles heel that makes it not fit very well. One theory is that the star is dimming and calming down after having recently ate a planet, but once again the chances of catching that just as it was happening are astronomical. It could be some sort of material passing in the foreground, but we've never seen that sort of thing before and comes with its own set of problems. So it boils down to this: whatever we're seeing at Boyajian star is a really rare phenomenon. If it's natural, whatever it turns out to be will be extremely interesting to science. However, if you have to resort to rare and unusual phenomenon to explain something, there's one more possibility that might be consistent with what was being observed to occur at this star. That would be gigantic alien megastructures. It is the least likely possibility and has problems of its own. Where is the heat going that it too would radiate? Why is the rate at which it is blocking out starlight increasing? Is it under construction? But if so, how is it being constructed so fast? The fact is, this mystery remains just as much of a mystery today than when the phenomenon first caught the public's attention, and the alien megastructure possibility still has not been discounted. So while it's very likely a rare natural occurrence causing this, the sticking power of the alien origin theory certainly raises eyebrows. Number 4. Life in the clouds of Venus. If someone would have uttered that Venus might harbor microbial life just a decade ago, they'd have been called crazy. Venus seems, at first glance, to be a place unable to host life of any sort due to being about as hostile of an environment as you can get on a planet. But in recent years, that's changed, and there does indeed appear to theoretically be a way for life to exist in Venus's atmosphere. The very first indicator is Venus's history. Just after the late heavy bombardment of about 4 billion years ago, Venus was not as it is today. Presumably, it would have been subject to the same amount of bombardment by comets that Earth and Mars were, which would have delivered to it plenty of water. Venus would have been warm enough for that water to exist as a liquid, and while we aren't certain how long it might have had oceans, the estimates vary wildly, some going as far as to say 2 billion years. The point is, there may have been plenty of time for microbial life to arise there. In fact, at that time in Earth's history, single-celled organisms were everywhere and actively oxygenating the atmosphere, setting the stage for something more than simple life. But if microbes did arise on Venus and water did persist for a long period of time, there might also have been enough time for them to adapt while Venus transformed itself into Hell Planet and become based in Venus's atmosphere in an area where the temperatures are Earth-like and comfortable. Coincidentally, in the same comfortable zone, there is some kind of material absorbing UV radiation. While there are some chemical possibilities to explain this, another possibility would be microbial life using the UV radiation as an energy source. And researchers have noted that the presence of sulfuric acid in Venus's atmosphere is not a showstopper for life. There is a way for life to coat itself with polymers known as S8 molecules to withstand the corrosive effects of the acid. As it turns out, S8 molecules have been detected in Venus's atmosphere. So it would seem Venus may have just as good of a chance of having microbes as Mars does. It's certainly worth checking out, which seems to be on Roscosmos' agenda as they plan their next foray to the goddess planet. Number 3. Martian meteorites. In 1996, a group of scientists from NASA announced that they had found structures that looked specifically like traces of microbial life in a meteorite known as Allen Hills 84001. It was such a sensation that Bill Clinton went on television and gave a speech about it. This meteorite bears characteristics that solidly point to Mars as the rock's place of origin. That part isn't debated. It's a rock that was blasted off Mars in an impact. And it's an interesting rock. It appears to have been exposed to water in the past, as would be expected on Mars, and seems to have once been part of a subsurface aquifer. Such places on Earth are often just right for life. The problem with the claim was that these fossils, if indeed that is what they are, which is still hotly debated, are significantly smaller than their counterpart microbes on Earth, below the generally accepted limit thought possible for microbial life. That's more than a little odd and gets into a debate about the existence of nanobacteria here on Earth, and those have been labeled the cold fusion of microbiology, and the debate over whether these structures in this and subsequently other meteorites linked with Mars are indicators of life has never been settled, but it does remain a possibility, especially in light of the next case. Number 2. The Viking biological experiments. In 1976, NASA landed the first 2 probes to successfully function on the surface of Mars. Called Viking 1 and 2, they both functioned for years as stationary laboratories on the red planet, taking high-resolution images and doing soil analyses. They were both highly successful as missions and greatly increased our knowledge of Mars. But the results of one experiment remain uncertain to this day for good reason. The experiment tested positive for active microbial life on the surface of Mars. Part of the problem was that this experiment directly contradicted another. The labeled release experiment showed that something was metabolizing nutrients in Martian soil samples, but the other experiment was intended to determine if there was organic material in the soil, and it indicated that there was not. Metabolism without organics is not what you would expect from life, at least anything similar to Earth's microbes. Now, the labeled release experiment seemed to be a pretty reliable indicator. It was thoroughly tested on Earth and never produced a false positive. Compounding this was the fact that both landers had the same experiments and both came up with the same results despite being 4,000 miles apart. It gets even stranger when you account for the fact that when the experiments were altered and done again after the soil was heated, the metabolic activity slowed just as it would here on Earth. So that led scientists to look to non-biological possibilities for the metabolism. There are several chemical processes that can mimic metabolism. One of these is formate, which can produce a false positive. But it seems likely that Mars wouldn't have a lot of that, and the experiment where it produced a false positive did not have a corresponding sterilized control. Another possibility is perchlorate, which Mars has been shown to have. The trouble is, perchlorate action does not slow down as you turn the heat up, so the Vikings should not have seen a slowdown in metabolism when heat was introduced. In 2013, a study showed that cosmic rays can make perchlorate break down. This yields hypochlorite, the action of which would break down under heat and produce the false positive. But proponents of the positive result being real, including the original researchers on the Viking missions, point out that hypochlorite hasn't been tested after long-term storage of the material, which when doing that on Mars led to a negative result, as though any bacteria present in the soil died off when stored. That leaves us without any solid non-biological candidates from which to produce the observed result. Fast forward again, in 2014, Mars Curiosity detected the presence of organic molecules on the surface of Mars. Why didn't the Viking experiments also detect organics if they were present? It turns out that Viking's gas chromatograph mass spectrometer that was used to look for organics might not have been able to detect them at all and was never designed to look for life in the first place. And that was even stated by the head experimenter at the time in charge of the instrument. The plot thickens. It has also been shown that the instrument would have required at least 1 million microbes to detect an organic signature. If there were fewer than that, the instrument would not detect their organics. To complicate things further, perchlorate destroys organic molecules, and if it were in the soil, and if it were present at the Viking sites, well, there goes the evidence for organics. The bottom line here is that if these experiments had been performed on Earth, where we unequivocally know that there is microbial action, the detection of life in the experiment would not have been questioned. Since they were performed on Mars, the bar is higher, and it's difficult to imagine microbial life withstanding the harsh radiation environment of the surface of Mars. But, on the other hand, we've seen microbes here that can apparently use radiation in their environment to their advantage. While a majority of scientists have not accepted this result, a vocal minority point out that life is the most likely explanation for the positive result in the labeled release experiment insofar as we know. I don't know what to think either way, but this does qualify as very possibly having been a detection of life on Mars. I won't attach my usual caveat of highly unlikely to this one for the simple fact that we're looking to send humans to Mars, and if there is any chance of alien microbes living there, we need to know about them beforehand. More experiments are needed to answer the question once and for all. Number 1. The WOW signal. Topping the list, perhaps unsurprisingly, is the infamous WOW signal. It is perhaps the most unfortunate case, however, in that since it never repeated, we are unable to study the nature of it and confirm whether it really was of alien origin. But even though it was detected in 1977, to this day, no satisfactory natural or technical explanation for it has panned out, and it remains the best candidate we've ever received for an artificial alien signal. Part of the reason that the signal is so famous is that it bore all of the expected hallmarks of a signal sent by an alien civilization, and contrary to certain claims, the signal did not contain any message. It was just a continuous burst of raw radio energy at the hydrogen line, which is considered the most likely frequency aliens would use to say hello, one that we on Earth intentionally do not broadcast on in deference to SETI. Now, the telescope that detected the signal was stationary and relied on the rotation of the Earth to scan the skies. Because of that, it was expected that any signal originating from deep space would be visible to the telescope for just 72 seconds, and the intensity of such a signal would rise for the first 36 seconds and then subsequently fall. Interference from Earth would not do this, and both characteristics were present with the WOW signal. And the bandwidth of the WOW signal was very narrow, which may further support the notion that it was artificial. Unfortunately, we don't know much else, and the discoverer of the WOW signal, Jerry Amon, warns that we should not draw vast conclusions from half-vast data, so the origin of the signal is still open for debate. One should always be skeptical of anything that doesn't have confirmation. But out of all of the potential signals that the various SETI efforts have detected over the years, this is the only one where one could reasonably say that may well have been it. There's little question that SpaceX's launch of Falcon Heavy was historic. This is a truly huge development in the exploration of space that allows an expansion of our heavy lift capabilities, but has also rekindled interest in space simply by virtue of launching something unusual, Elon Musk's Tesla Roadster. The Roadster launch garnered the attention of tens of millions on YouTube alone, making it well worth it as far as science outreach and inspiration goes. But launching odd items into space in general is nothing new, and in fact, the Roadster might not even be the strangest object ever launched. So here are 10 really unusual items humans have launched into space. Number 10. Mutating tomatoes. Flying tomatoes into space on its face isn't surprising. They are a popular food item. But what happens when you fly them just to see what space does to them when you grow them back on Earth? Oddly, this has happened multiple times. The first story here is rather murky, the cosmonaut Volkov tomato. Heirloom tomato gardeners will probably know of this variety of tomato as it's commonly available in seed catalogs. But how did it get the name of a famous cosmonaut? As it turns out, there are two stories floating around. One is that the Soviet Union launched tomato seeds into low Earth orbit and then distributed them for cultivation after landing to see if exposure to space did anything, and it's been bred ever since. Another is that a Soviet space program engineer developed the strain here on Earth and simply named it after his friend, cosmonaut Vladislav Volkov, who died in an accident in space in 1971. Regardless of which account is true, someone bringing tomato seeds into space and returning them safely to the Earth to see what would happen is a certainty. Back in the 1980s, NASA brought them up on the space shuttle and then left them on a satellite, then retrieved them sometime later and distributed the seeds to schools for in-classroom experiments. Everything was all fun and games until someone suggested that exposure to cosmic rays could have mutated the tomatoes and made them poisonous once grown. It turns out they were fine, and even more seeds were sent to the ISS in 2016. Those, however, stayed safely in the space station and were mostly just subject to a period of zero-G. I haven't eaten any of NASA's space tomatoes, but I have grown cosmonaut Volkovs, and they're delicious. Number 9. Dinosaurs. Not only have the dinosaurs been to space, but twice, though they weren't alive at the time. In 1985, 76-million-year-old bits of bone and shell from a Maiasaura peoplesorum were flown on Space Lab 2 for no other reason than it seemed like a cool idea at the time. In 1998, a small dinosaur skull was flown to Mir and returned to Earth, again because it was cool. I certainly get the concept of science outreach and doing cool things in space just because they're cool, But somehow, I doubt the dinosaurs would have been too happy with this, especially in light that their extinction was directly related to space. Number 8. The Man Who Discovered Pluto. I doubt astronomer Clyde Tombaugh would have ever thought, as a young man, that he would go on to discover a planet, and then that planet got demoted to a minor planet, and then Tombaugh would go on to fly past that planet, yes, planet, at a breakneck speed and then rocket off into space to become the furthest human as such from Earth. But that's what happened. While studying photographic plates using a device called a blink comparator to look for minute movements of objects in space, he ended up discovering Pluto. He also discovered quite a few asteroids using this method. A sample of Tombaugh's ashes were included on the first spacecraft to visit Pluto, New Horizons. And if that's not cool enough, Tombaugh may technically become the first human to leave the solar system. Who knows where his ashes will end up? But oddly, also included on this mission was a nuclear power source consisting of plutonium. This element was named after the planet Pluto to keep in line with the then current naming scheme of newly discovered elements. They were named after planets, such as uranium and neptunium. Trouble is, Pluto has been demoted, which makes it sort of ridiculous that we have an element named after a former Kuiper Belt object. But good luck renaming plutonium. Given that New Horizons also revealed that Pluto was far more interesting of a world than we could have ever imagined, and it's so ingrained in global and scientific culture, Mickey Mouse's dog is named after this thing, I think maybe we should start calling it a planet again, or at least give it its own classification, perhaps call it a plunaut. Number 7. Really crazy handguns. You normally wouldn't think you'd need a gun in space, and even if you did, firing it in an airtight spacecraft would be beyond dangerous. But for years, Soviet cosmonauts were in fact equipped with firearms, and they were no normal handguns. They had triple barrels. The reasoning for packing heat was simple, and it had nothing to do with encountering hostile aliens. The truth is, capsules parachute landing in Siberia might not be immediately retrievable, leaving cosmonauts on their own until help arrived. Given that there are dangerous animals living in Siberia, such as bears and wolves, it was deemed necessary for the cosmonauts to be ready to defend themselves if need be, or even hunt. Number 6. Delivery pizza. It's the age of pizza. From its simpler though really delicious beginnings as a local food in Naples, Italy, this food has taken over the world, and pizza restaurants serving hundreds of variations can be found ubiquitously in numerous countries, and that trend grows. One of the hallmarks of pizzas is that they are easily delivered if the customer wants to order in, and they make for awesome leftovers the next day. But has pizza left Earth? Yes. In the furthest reach of pizza delivery so far, Roscosmos delivered a pizza to the International Space Station in 2001. Commissioned to do so by Pizza Hut, and costing that company over $1 million, the delivery pizza was consumed by cosmonaut Yuri Yusakov. But exposure to low Earth orbit conditions deadens taste buds, so the company spiced the pizza up a bit more than usual, and had to use salami as a topping due to the delivery taking far longer than the usual half hour, raising questions about toppings and shelf lives in a space capsule traveling to the ISS. Even still, the cosmonaut gave a thumbs up after dinner and seemed to enjoy it. Number 5. Golf equipment. In 1971, NASA astronaut Alan Shepard famously pulled out a golf club and shot a few golf balls on the lunar surface during the Apollo 14 mission. While we don't know the actual numbers until someone actually goes up there and finds the golf balls if they haven't disintegrated and actually measures it, this was almost certainly a semi-permanent golfing record, as one of the golf balls may have gone for miles. Oddly enough, this was probably not sanctioned by NASA. Story is, Shepard smuggled a makeshift golf club head on the mission and mounted it on a lunar sample-taking instrument and just went ahead and took the shot. That makeshift golf club made it back to Earth and is displayed in the USGA's museum. Number 4. A poster for a minor Val Kilmer movie stuck to a wheel of cheese. Alright, this was SpaceX again and Elon's humor. In 2010, it was revealed that aboard SpaceX's first Dragon capsule there was a wheel of cheese, a nod to a Monty Python sketch where John Cleese wanted to buy cheese from a cheese shop that didn't carry it, along with an image of the movie poster for the Val Kilmer movie Top Secret. Anyone remember that one? Oddly, this time SpaceX chose to keep their cargo secret until after the launch, as not to overshadow the success of Dragon. With Falcon Heavy and the Tesla Roadster, clearly they have gotten over this shyness about their occasionally odd cargoes. Number 3. Salmonella. It's only natural to study Earth bacteria in space. What can be learned from doing so can shed light on human illness and treatments. Salmonella is no exception, and it was flown twice on the space shuttle to the International Space Station. While it may not be all that weird to fly Salmonella, what happened to it while it was in space certainly was. You would think taking an organism out of its native environment would put it at a disadvantage and weaken it. Not in this case. The Salmonella became 3 to 7 times more dangerous after spending time in space. It appears that the bacteria were tricked into thinking that they were inside a human body rather than space. This is believed to be because of fluid shear. Once they attach themselves to the walls of human intestines, the Salmonella bacteria experience a condition of very low fluid shear, which might signal them to switch on certain parts of their genome and, well, become more dangerous and make their host sick. As it turns out, zero gravity is also a low fluid shear environment. Number 2. Nudes. Clothing on Earth is a cultural thing. Most human cultures prefer some form of it, especially if they are native to cold climates, but not all. As a consequence, it may be that the entire galaxy is clothing optional, depending on the species and culture and the environment they evolved in. Though I would say it might be reasonable to expect one piece of clothing that might be common among most biological spacefaring species, the spacesuit. That aside, if you look at most representations of humans in our cultures, our photographs, other technological records of us, say our television broadcasts that aliens might intercept, they would see us as a strangely clothed species. Perhaps the aliens might wonder if Batman's suit was really a part of his body, or they might think the whole thing's silly and wonder why we once restricted ourselves with steel armor in battle instead of genetically modifying ourselves to grow a decently protective carapace. But some scientists on Earth would have no part of this clothing thing, and felt it best to depict humans as we really are. It was Carl Sagan, Eric Burgess, and Frank Drake, and they rightly surmised that, well, one thing about humans is that we're all naked under our clothes, so Sagan went with depicting humans as humans in all our glory. It's the Pioneer plaque, and there are 2 of them, one on Pioneer 10 and one on Pioneer 11. It's actually pretty unlikely anyone will ever intercept our nudes we've sent out. In fact, it may be more likely that we intercept them and take them back to museums in the future. But if left on their own, the plaque on Pioneer 10 will eventually pass near the star Aldebaran, and then on to parts unknown. It's anyone's guess what Pioneer 11 will eventually encounter. In other words, we've lost control of our nudes and they are happily gallivanting across the galaxy. Number 1. The nuclear manhole cover. This one may or may not have made it into space. This is something that has been debated for years, but if it did, and we'll likely never know, it would be among the first man-made objects into space and probably the strangest. It all goes back to a nuclear test conducted in 1957. During this test, a 2,000-pound steel plate was placed atop a test shaft. As the experiment detonated, it traveled up this shaft and propelled the plate into the air at about 6 times the escape velocity of planet Earth. What happened then is anyone's guess, though no trace of the plate was ever found. It might have vaporized in the atmosphere, or some parts of it might have made it into space and off into the solar system and beyond. So count Elon Musk's Tesla Roadster as just the next in a long series of odd objects we've sent into space over the years, and we should send more. Who knows who might pass through the solar system and find our remnants floating in space. After all, one species' trash is another species' confirmation that they are not alone. One could argue that almost any body in the solar system is habitable so long as you have the technology to colonize it, but that would involve this solar system's elephant in the room, which is our civilization. For the sake of this list, I leave us off it. We know that life on Earth is possible, but as we've learned more about our solar system, it is becoming increasingly evident that other places could have evolved life independently of Earth. So here are 10 places where life is possible in this solar system other than Earth, plus a few bonuses tossed in since hypothetical habitability is by no means rare in this star system, and probably isn't rare in the rest of the universe either. Number 10. Venus. This possibility is a long shot, though life can be tenacious and surprising, so it remains a possibility, at least for microbial life. Venus was once like Earth. It may have had abundant liquid water early in its history, and seems to have had it long enough for life to arise. But the story of Venus is a sad one. Several contributing factors led to an eventual runaway greenhouse effect on that world that turned it into a vision of hell. But that transformation would have been a gradual process as far as we know, and any life that was present on the surface may have had time to adapt to the changing conditions and find a niche in which to survive. That niche lies in the upper reaches of Venus's atmosphere. There exists a zone that is temperate and cool that may allow for airborne life to exist, and it's possible that we may have already detected it. This option for microbial life is a huge maybe. Venus's atmosphere is quite acidic, and this life would be radically different from most life on Earth. But there is a hypothetical way for life to exist in that kind of acidity through a molecule known as an S8 molecule. An organism could hypothetically incorporate S8 molecules as a sort of armor, as these molecules are resistant to the effects of sulfuric acid. S8 has been detected in the atmosphere of Venus, and could have been put there by life. Such life could also use ultraviolet light from the sun as an energy source, and oddly enough, when we look at Venus in ultraviolet, we see mysterious, unexplained streaks in the atmosphere. One of the possibilities on the table for whatever causes those streaks is microbial life. Number 9. Pluto. For this option, we go from the inner solar system to the outer solar system. One of the most surprising discoveries of recent years was that Pluto and its moon Charon were not merely frozen solid worlds, but in fact dynamic bodies with active geology and even abiotic organic chemistry occurring. With this, Pluto has gone from seemingly being one of the last places you would expect to find life to one where it is hypothetically possible. For life, you need energy, organics, and water. Pluto has all three, though on the surface the water is frozen, but it may have a liquid water ocean beneath the surface heated by radioactive decay in the planet's core. This has potentially enormous implications for life in the solar system. Pluto is thought to essentially be a nothing special Kuiper Belt object, one of hundreds or thousands. But if it does have that mix of radioactive decay and subsurface liquid water, then potentially many Kuiper Belt objects have this as well. If that's the case, then we may someday discover hundreds of new candidates for life in the solar system. Number 8. Triton. Speaking of Kuiper Belt objects, our next candidate is thought to also have originated from the Kuiper Belt. There's a good reason to think this. It orbits in the opposite direction of Neptune's rotation, suggesting that it did not form along with that planet. Plus, it looks similar to Pluto in a number of ways, but it does stand out in one very odd way. It's currently geologically active, but instead of volcanoes, it has cryovolcanoes that spew out nitrogen, contributing to a thin atmosphere. Another thing that sets Triton apart from most of the other moons of the solar system is that, because it was likely captured, it would have been subject to tidal heating from Neptune as it settled into a stable orbit. This could have created a Europa-like situation where there might have been subsurface oceans, and they would likely have persisted for a very long period of time. But how long? Are they still there? One clue is that Triton appears to have a young surface, only about 100 million years old, and may have resulted from an extrusion from the ocean below, and something is driving the cryovolcanism, so one possibility is that there is still a subsurface ocean present there. If so, it would likely be rich in ammonia as well as water, and could contain life. Number 7. The moons of Uranus. As we work our way inward from the outer solar system, we next arrive at a planet that really doesn't get enough attention. I'll admit my own bias here. I've never talked extensively about Uranus or its moons on this channel, despite having said the word Europa like 100 times. Perhaps it's simply because Uranus is not exactly the most photogenic of the planets. All Voyager 2 saw was a featureless blue-green sphere, though subsequently clouds and other activity have been seen. As a result, not a lot of attention has been paid to this planet. But looks can be deceiving. Uranus hosts mysteries just like all other bodies in the solar system, including how it came to be that this planet rotates on its side compared to the other planets. Best guess there is that early in its history, Uranus got smacked by an Earth-sized protoplanet. The first candidate moon for liquid water is Titania, though unfortunately so little is understood of this body's evolution that its candidacy is up in the air. But it is possible, at least as far as we know, for an ammonia-rich or salty liquid water layer to exist deep under this moon's surface. It's much the same story for Oberon, another candidate. We just don't know enough, but a subsurface liquid layer is on the table. Less likely is Umbriel. It's been suggested, but there doesn't seem to be much room there for anything but ice and rock. Uranus is a place where life is unlikely but marginally possible, at least as far as current thinking. And with all candidates mentioned for Uranus, you need more than mere water for oceans to persist. You need ammonia or salt as a sort of antifreeze to keep everything liquid. But life is in principle still possible here, so on the list the Uranus system goes. Number 6. Space itself. The last place you might choose to look for alien life is space, as in actual space itself. We tend to automatically think that life must be intrinsically linked to planets or moons, and that's certainly a fair point. It's hard to see life arising in the cold vacuum of space, but nothing says that life can't leave its planet. Stating the obvious, one way to do this are rockets and spacecraft, whether you are a human intentionally going into orbit, or you're a dog or chimpanzee being put there by a human, or even a stowaway bacterium, tardigrade, or lichen unintentionally leaving Earth, either by way of a spacecraft or through various methods of natural panspermia. But the possibility of natural panspermia comes with another possibility, that life could adapt, survive, and live in space on its own. We know that certain examples of Earth life, rare though they are, can survive the conditions of space. But what of something that can go much further? Freeman Dyson envisions one such possibility. Termed Dyson sunflowers, these would be organisms that might originate on ice-shelled moons, growing up through the cracks in the ice with a connection to the water below like the roots of a plant. It might adapt itself to keep warm through natural mirrors and might create its own supply of liquid water. It might even eventually be knocked off its planet and move into deep space and might adapt. I think this option is possible, but not probable. I doubt we would see life like this very often when exploring the universe, but it pays to remember that life often surprises us down here on Earth, and I see no reason it wouldn't surprise us in space. Number 5. Titan. Here we move to a moon that not only has one possibility for life, but two. It is a body different from all others in the solar system save for Earth. On its surface, it boasts liquid hydrocarbons mimicking the water cycle on Earth. It has been advanced that hydrocarbons in liquid form could serve as a solvent for life, like water does for us. This life would be very different from what we're used to. It would need to exist at much lower temperatures than here. But Titan is also so sufficiently strange that the possibility is worth consideration. One thing in favor of life on the surface of Titan are, again, abundant organics, and there may even be hints that there might be life there, such as difficult to explain methane levels at the surface. Though there are also natural possibilities for creating that, life is merely one option. But how might that life work? One thing that's been advanced are cell membranes involving acrylonitrile that could work with liquid methane as a solvent, and, lo and behold, acrylonitrile was found at Titan by the Cassini mission. Only time and more study will tell if there is life on the surface of Titan, but it too is an ice shell moon, thought to have a liquid water ocean high in ammonia below the surface where life may have also arisen. Perhaps there are two separate forms of life on this little orange moon. But Titan also presents an interesting future scenario where life is concerned. Say it has arisen there or someday will. In the future, as the sun goes red giant, Titan may get substantially warmer and undergo a greenhouse effect, in which case the life on the former surface may extinguish, but the life below may get a few 100 million years in the sun in the form of a surface ocean. Number 4. Enceladus. Enceladus is a place where the possibility of subsurface water is far more than a maybe. The stuff literally sprays out of surface cracks into deep space right before our eyes, and it's very nutritious water for life as we know it, very likely made so by subsurface volcanic vents. This is a tantalizing environment, but there's a problem. It may not be old enough for life. The problem here is that some of Saturn's moons orbit in such a way that suggests that they couldn't have been doing it this way for long. It places an age on Enceladus, at least as we know it now, of about 100 million years. That doesn't leave life much time to arise, but the question is open. However, there is one particularly odd feature of Enceladus that may be related to number 1 on this list. Do you see those cracks on the surface? Do you see how the extruded material is bluish, like clean ice? Take note of that for later. But in the end, even if there is no life there now, Enceladus seems well suited for it to arise, leading to the possibility that it may someday be a laboratory where the human race watches the advent of alien life in real time. Number 3. The moons of Jupiter. Moving from the Saturn system to Jupiter, we find a place where all 4 major Galilean moons can hypothetically host life. Least likely here is Io. It's wildly volcanic, but it is warm and it is thought to have once had water, so maybe something clings to existence deep in a moist lava tube. Also included here is Callisto, a rather ignored moon that could host a subsurface ocean. Then there is Ganymede, the largest of Jupiter's moons. Current thinking is that it doesn't just have one ocean, but several, all stacked one on top of each other, separated by layers of various forms of water ice. Think of it like a high-rise building with different floors. Any of these oceans may harbor life, and may even host different ecosystems that interact through cracks in the ice. I'm sure you've noticed that I ignored the obvious candidate for life in the Jupiter system. I did that on purpose, as it tops this list. Number 2. Mars. In both science and the world of science fiction, Mars has always occupied a prominent place as far as pondering extraterrestrial life is concerned. There is something alluring about it, the red planet, that in some ways looks very much like Earth, the solar system's ultimate abode for life, but also strangely alien. It's like an alternative Earth in a way, a twin that isn't identical but similar enough to be a little spooky. But that similarity extends to the scientific. Mars was once a habitat very much like Earth with abundant liquid water. Now it is cold and dry, and in fact, the famous streaks that were thought to be evidence of salty seeping water on the surface is now in question. Still, liquid water could persist on this planet deep below in aquifers, allowing a refuge for life that might have survived the Great Drying. But it would almost certainly be microbial in nature. But in the end, life is life. But what hints have we seen that something could still be hiding out on this world? First and foremost were the inconclusive Viking experiments that gave positives from metabolism in samples in an experiment designed to detect life. But unfortunately, the results were called into question and remain so today. It's anyone's guess if they did detect life, and it's also debatable as to how surface life could exist in such a harsh radioactive environment. But there's more. It's been known for a while that something weird is going on with Mars and the gas methane. It was detected in the Martian atmosphere back in 2009, but the trouble is that methane is destroyed in that environment, so something must be replenishing it. The mystery deepened when the Curiosity rover detected a massive 10-fold rise in methane levels at its location at Gale Crater, only to then see the levels drop back down to normal. There are natural ways for this methane to be released geologically, but it also happens to be that methane is also a gas associated with active life. Number 1. Europa. Europa probably has the best chances of harboring life in the solar system other than Earth, and that life may even be more than microbial. It has a subsurface liquid water ocean that interacts with its surface. It has geysers that periodically spew materials from the ocean below into space. It has an energy source in the form of geothermal energy from tidal flexing, and essentially it has, as far as we know, the right mix for life to arise. And we may have already seen evidence of it. In 2003, a team led by Brad Dalton looked at the infrared signatures of the cracks in Europa's surface where odd discolorations are visible. He then compared that with microorganisms here on Earth located around geothermal springs at Yellowstone. They matched, opening the possibility that the discolorations are due to the presence of frozen microorganisms from the ocean below. Taking it further, Dalton took extremophile microorganisms native to Earth and put them in conditions similar to what's found on Europa. He looked again in infrared, and there were still correlations, but not a perfect match. A mineralogical answer was looked at, yet no combination of salts fit either. Yet the pink and brown discoloration of the cracks itself might be telling. Salts should appear white, yet the extremophiles used in Dalton's experiments are colored pink and brown. While this is by no means conclusive, the discolorations could well be mineralogical. The mystery probably won't be solved completely until we can get samples of Europa's ice or drill into the ocean itself. But if I had to bet on any body in the solar system hosting life other than Earth, I'd bet on Europa. But back to Enceladus for a moment. Europa and Enceladus are very similar moons. One has cracks with staining present, the other does not have that staining. What is so radically different between these otherwise very similar objects? Recently, the Mars Curiosity rover found a curiosity, an iron meteorite sitting on the surface of Mars. While probably not much different than iron meteorites from the asteroid belt that also fall here on Earth, the folks at JPL are taking a look anyway to see if there's anything interesting going on. In celebration, here are 10 really strange and unusual meteorites that have landed here on Earth. Number 10. Pieces of Vesta. While most meteorites that fall to Earth originate in the asteroid belt, occasionally we can study the chemical makeup of these meteorites and compare them to what we know about the compositions of asteroids and nail down specific meteorites that originate from specific asteroids.
While several meteorites have been linked with their parent asteroids, the most noteworthy are a group of meteorites that originated from the asteroid Vesta, one of the largest in the asteroid belt and an asteroid that the Dawn spacecraft visited and studied throughout 2011. It was learned that Vesta underwent a huge impact sometime within the last billion years that explains why so many meteorites from it have fallen on Earth. While not really rare but not common either, these meteorites, called chondrites, are igneous in nature and stand apart from normal meteorites, which are typically much more primitive conglomerations of much older material. This has yielded much information about the makeup of the asteroid Vesta. Number 9. The Ensisheim Prisoner. On November 7, 1492, a very unusual thing happened in France. Numerous people, including the artist Albrecht Dürer, observed the fall of a meteorite in a wheat field in the town of Ensisheim. Amid much superstition and talk of an omen, the local townspeople picked up the pieces, which caught the attention of the son of the Holy Roman Emperor Frederick III, whose local magistrate ordered the stone preserved. While some bits and pieces of the meteorite were sent to notable people such as the future Pope Pius III, most of the stone was chained up in the local church to prevent it from wandering off the way it came. There it stayed for centuries, but now it's no longer chained up and it's now kept in a local museum pretty much intact and just as it fell 5 centuries ago. Number 8. Moon rocks you can own. Meteorites from the moon aren't so much a mystery of why they would be here, we are right next to it, but why we have so few of them. As one of the rarest materials on Earth, lunar meteorites are eagerly sought after for scientific study, even with all of the samples brought back by the Apollo missions. That's because they tell us about the diversity of lunar geology being from areas of the moon where we have not been. But they can also be privately owned. Certain lunar meteorites, usually originating from finds in the deserts of North Africa, are weathered from hundreds of years of being on the surface of the Earth, and as a result are less interesting to science and can be bought from reputable meteorite dealers, though cheap they are not. Number 7. The Stone of Emissa. In the ancient Greco-Roman world, strange stones were revered as religious objects. Called an omphalos, some of these stones were probably meteorites, thought by the ancients to be rocks Zeus was throwing from Olympus. One such stone, called the Black Stone of Emissa, seems to fit the bill as a meteorite, though we can never be sure. But it certainly had quite a history. The insane Roman Emperor Elagabalus, for example, had it transported to Rome so he could revere it, and apparently had plans to marry it. That did not happen. He was assassinated, and the stone was returned to Emissa by the much more down-to-earth emperor that succeeded him. Number 6. Canyon Diablo. Sometimes the meteorites themselves are less famous than the effects they have on the planet. The Canyon Diablo meteorite is one of the most common meteorites. It's so common that you can buy pieces of it at a gem show for just a few dollars. It's also an interesting meteorite containing more than just crystalline iron and nickel from the core of an asteroid, but also odd graphite inclusions and even diamonds. And it also happens to be the meteorite that created the mile-wide meteor crater in Arizona, Earth's best preserved example of what happens when a meteorite the size of a house hits a planet. Number 5. The Near Miss. Occasionally, a meteorite will enter the Earth's atmosphere at a shallow enough angle that it will skip back off into space. That very thing happened in 1972 when a large meteorite thought to be between 10 and 45 feet wide entered the atmosphere above Utah and tracked northward over Alberta until exiting the atmosphere completely. This is thought to have consumed about half of the mass of the object and greatly altered its orbit. Though not certain, some suggest it still passes close by Earth. Perhaps we'll get it yet. Number 4. The Big Smack. And then there are the big meteorites that do find their mark. For some reason, this often happens in Russia, presumably due to the enormous size of that country. In fact, just a few years ago, a large meteorite made headlines as it was filmed detonating wildly in the upper atmosphere over Chelyabinsk, releasing a total amount of energy equivalent to 29 Hiroshima atomic bombs. It also generated a shockwave that shattered windows and tragically injured residents across the region, even causing sunburn on some people, it was so bright. But that was not a once-in-a-lifetime event. And no, I don't mean the famous 1908 Tunguska event. On February 12, 1947, local residents in the Sokoty-Alin region of Russia saw a massive bolide brighter than the sun passing overhead, leaving a trail of smoke in its wake. Due to this meteorite being made of sturdy nickel iron, a large portion of it made it to the surface of the Earth, about 80 tons. It literally went off like a hand grenade in an airburst close to the ground, littering a mountainside with twisted pieces of iron meteorite shrapnel. Had this happened in a heavily populated area, the effects would have been devastating. Number 3. Allende. Meteorites can be heavily modified by geologic processes, creating changes due to pressure and even melting, but sometimes they are not and can represent windows into the early days of our solar system. Just such a meteorite was observed to fall in 1969 over Mexico. Locals in the area of a town named Pueblito de Allende picked up literally tons of meteorites, which proved to be a boon for scientists. Allende turned out to be a very primitive meteorite that included calcium-rich inclusions within the meteorite that are the oldest objects native to our solar system, having been the first materials to condense out of the early solar nebula. But it doesn't end there. Also contained within the meteorite are grains of matter that predate the solar system and originate from interstellar space. Number 2. The Murchison meteorite. Asteroids and planets are not the only sources for meteorites in our solar system. I would be remiss if I didn't include comets, which can be the sources of some of the most interesting meteorites that give us clues about the origins of life on Earth. Observed to fall in Australia in 1969, a few months after its cousin Allende, the Murchison meteorite provided another unique perspective on our early solar system to the scientists of the time. Given that this meteorite was observed to fall, samples were picked up very early before the meteorite had time to be contaminated by Earth's environment. It was so fresh, in fact, that when researchers opened up bags containing the meteorites, they were hit with a strong alcohol-like smell, hinting that this was no normal run-of-the-mill meteorite. They would go on to find that this meteorite contained unusual amounts of water, alcohol, hydrocarbons, and something much more interesting. Contained within this meteorite, which is thought to have possibly originated in a comet, scientists found amino acids, the building blocks of life. While abiotic, you don't need life to create these amino acids, they suggest that the building blocks of organic chemistry and life itself were delivered to Earth by primitive asteroids or comets. Number 1. The meteorites of Mars. The planet Mars has also been a source of meteorites that offer tantalizing hints that Mars once supported life. See my video on the Allen Hills 84001 meteorite for an in-depth exploration of that meteorite. But it's not alone in its strangeness. In 2014, researchers found that another meteorite found in Antarctica known as Yamato 000593 appeared to have been altered by liquid water in the past and contained tiny tunnels and carbon-rich spherules that may have been formed by life. By comparing this meteorite with another known meteorite from Mars where the same tracks were found, they were able to show that the tracks were probably not of earthly origin and were present in the rock before it fell to Earth. Taken in conjunction with disputed findings from Allen Hills 84001, which also seem to contain what might be traces of bacterial life, these findings are tantalizing to be sure, but they do not constitute proof that life exists or once existed on Mars. For that, we need samples directly from the surface of Mars that rule out any possibility of Earth contamination, and even then, we need unique non-Earth DNA or chemistry that can only have been created by life. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently with the windows open, enjoying a nice fall day. And be sure to check out my books at your favorite online retailer and subscribe to my channel for in-depth, regular explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.